Well,
Good morning, everybody. Good afternoon and good evening. Can you guys hear me correctly? All right. Welcome to the second day of HotStorage 2021. First of all, sorry for the flip background yesterday. I hope it is fixed now. Today, we have two exciting sessions and one panel discussion. The first session today is about the new technology in the storage system, such as DNA storage and row hammering issue in the storage system. The second session today is about the storage and workload characterization and verification. And also we have an exciting panel discussion session with 4 panelists. The theme of the panel discussion is from ideas to products, the path of the successful storage startups. And we have created jobs Slack channel for job postings, and it is open to all participants. And you are welcome to place job postings any relevant issues at the jobs channel. And please visit the jobs channel for your job postings. I hope all of you enjoy HotStorage 2021 till the very end. Thank you. And Phil?
Yep, and welcome. Thanks to everyone for joining today, and look forward to an exciting set of sessions and panel. And now we'll begin our first session of the day.
hello, everyone. Can you hear me?
Yes.
Okay,
Yes.
so this
Yes,
is
I can hear.
very good. This is Shamali Chatterjee from Purdue University. So myself and my co-chair, we will be moderating this exciting session for all of you. The first talk in this session is DNA archival storage, bottom-up approach. And the person who's going to be presenting it today is going to be Omer Salah. And this team is spanning over the University of Cambridge, where we have Omer and Andrew, and Imperial College London, where we have Jasmine and Thomas. And Omer is an independent biologist. So Omer says that the science behind DNA storage is proven, and they are working to make it happen in real life. With that, I will pass it on to the video recording for Omer's talk.
The purpose of this work is to present tools to encode data into DNA as a function of process constraints. So not a single encoding, but a recipe to produce such encodings. DNA data storage uses synthesis for writing and sequencing for reading as a constrained medium. As an abstract model, one can think of synthesis as adding base by base to a growing chain or strand. With respect to sequencing, there are at least two sequencing methods at present. One is nanopore sequencing, and the other one is sequencing using polymerase chain reaction, or PCR. On either synthesis or sequencing, PCR is used to increase the concentration of a DNA strand, and it is very similar to the function of an amplifier, which is also why we call it amplification. DNA synthesis is open to anyone, so starting from a file and a basic mapping from bits to bases, you can generate text sequences of bases and send them to a synthesis company through a web interface and get your data synthesized as DNA. If you are not aware of limitations on the data, this would be a point where the synthesis company would tell you about them, and they may reject some of your sequences, mark them as difficult, or price them differently. And these include homopolymers, GC content, GC variants, and short tandem repeats, which we'll explain immediately. Homopolymers are sequences that are made of multiple continuous repeats of the same single base. GC content is defined to be the ratio between counts of G and C in the strand and the length of the strand. Too much of it or too little of it might be a limitation. Variance of GC content between two adjacent stretches of strands, so one could have too much GC content and the other one has too little, or just the difference between them is too large. Short tandem repeats are sequences in which there are multiple consecutive repeats of the same short subsequence, and there could be a limitation on the number of consecutive repeats on such a strand. In addition, certain reserved short subsequences may mark where sequencing should begin, and their appearance in the data payload may result in fault. The way we treat these constraints in our work is by considering mapping bit sequences into DNA sequences of a fixed length, K, rather than single bases. The idea is to concatenate subsequences of length K that comply with all constraints, so that a constraint could only be violated at the concatenation point. The choice of K should be short enough that a symbol of length K does not contain any violation already. At the same time, note that there are 2K bits in a symbol, and if we're going to be reserving some of them to resolve constraints, then each reserved bit increases the overhead by 1 over 2K, so K should be as large as possible to reduce overhead. We enumerate the symbols, and we form a connectivity matrix so that A at coordinate ij equals 1 if symbol j could be concatenated to symbol I, and 0 otherwise. This allows us to approximate the theoretical capacity of this K symbol channel given in this equation. In the paper, we give an example of multiple constraints. The first one is maximal number of consecutive identical bases being 5, so 6 is a violation. If we focus on the row for symbol CCCC, we can see that no symbol between CCAA and CCTT can be concatenated to it. Finally, in this example, we have a limitation on GC content, which is allowed to be between 15% and 85% in the concatenated two symbols. So for example, if we want to focus on the orange square, we can see that CCCC cannot be concatenated to CCCC, for example. So when we put them all together, we get a matrix that corresponds to all constraints concurrently. And one, for example, could focus on the symbols being concatenated to TTTT, and one can see that AAAA could not be concatenated to it. For example, this could be because the result has too little GC content. But if you look at GGAA, it could be concatenated to it. So if we were to reserve the first two bases at most, we know that we could resolve that conflict or that restriction for TTTT. Reserving bits on the right-hand side symbol corresponds to reducing the connectivity matrix. Specifically, splitting the connectivity matrix in half about the center and taking the coordinate-wise maximum between the left and right sides. Each such iteration corresponds to 1-bit reservation, and we stop once we reach a matrix with 1s in all coordinates, or when we have reduced the original matrix to a single column. The example in the paper requires not 1 but 3 iterations, but eventually when you reach a matrix which has no zeros in it, that is the all 1 matrix, you can concatenate any partial symbol on the horizontal axis to any symbol of length k on the vertical axis. So far we haven't chosen any specific values for our reserved bits. We just calculated how many bits will be needed to resolve any constraints at the concatenation point. And in that sense, it's an easy tool to compare between different processes. To make this into a specific encoding, we need to retrace our steps, meaning how we got to the all-1 matrix, and choose specific values for the bits we reserved in order to make any concatenation between two symbols legal. So continuing our example, suppose we have a symbol coming from the left saying AAAA, and another symbol coming from the right saying 0AA with 3 reserved bits. We need to choose one of the options for the 3 reserved bits so that there is no violation at the concatenation point. We could choose, for example, 1 to complement the 0, and that will give us a G, and we can choose, for example, a C for the remaining base, which is reserved. We end up in a very natural way with a finite state machine, where our current state is determined by a length k symbol, and upon input of a partial symbol and a choice of specific reserved values, we transition to the next state and output a full length k symbol. Our current work includes choosing the specific values for the reserved bits wisely, and that is also coupled to the next question, which is, can we use the Viterbi decoder for this, since this is a finite state machine encoding? If we manage to use the Viterbi decoder, this could be an error correcting code, and we could compensate for insertions and deletions. Thank you for watching, and we look forward to your feedback.
Hi, Omer. Can you turn on your video and audio?
Yeah, absolutely.
Very good. So congratulations on the Intel and Samsung Best Presentation Award. I'm guessing you were taken by surprise when I told you that. So congrats on that. So I will start with the first question from Philip Schlein from Dell Technologies. What is the mechanism to generate the DNA with a given pattern, and where is it physically stored?
Okay, so I don't want to advertise any specific company that does this. You could basically Google DNA synthesis if you want specific companies, but I'll answer about the mechanism. So each nucleotide is a molecule, and there are 2 processes, one chemical, one enzymatic, which are common. I'm guessing there are more. I'm not a biologist, so take everything I say with a pinch of salt, right? Where you basically build the strand or build the physical sequence 1 nucleotide at a time by adding nucleotides one on top of each other. So this is synthetic DNA, meaning you can send whatever sequence that you want of A, C, Ts, and Gs and get that back as a powder or in a tube. With respect to natural DNA, so we know natural DNA lasts for thousands of years, I would say even more. It is sensitive to UV light, but a good paper by Nick Goldman, I want to say from 2016, basically said you could stick it in a cave and not worry about it for thousands of years.
And that's
So
natural DNA, right?
That's natural DNA.
So the related question is, how long is this stable, and is it repaired over time, the synthetic DNA? And is there the possibility, this might be a naive question, to use natural DNA in the future?
Sorry, so could you repeat the question?
Yeah, I said this synthetic DNA, where is it physically stored? How long is it stable? And is it repaired over time?
Okay, so physically you can store it. So some labs or some partners that we have just stored it on the shelf, right? Just protected it from UV light and just stored it on the shelf. Refrigeration is one option if you want to keep it more safe. Some of the experiments we're doing right now is about what's the durability of a DNA strand with respect to its length and environmental conditions, especially synthetic rather than natural. But we expect it, but our guess is, and again, I'm not a biologist, our guess is that it's roughly the same.
Okay, so the next question is from Yujik Wan. What is the read and write bandwidth for this technology? And I had the same question. When is it going to be commercially available?
Okay, so I would say that the word commercially is kind of, let me put that aside for a moment. The read and write bandwidth. So with respect to read, the good thing here is that you have something called, or you have a mechanism that's called PCR reaction. We don't, I want to say, really have that in most media, which means you can duplicate the original strand, the original DNA many times before you try to read it. So the bandwidth is only limited by the amount of sequencers that you have. Basically, you could parallelize this many times. The write bandwidth is a little bit more hard to understand. It depends on the synthesis company. Latest numbers that we have are about, it's very low. It's about 2 minutes per 2 bits, which is extremely low. So that's, I want to say, that's the where we put back the word commercial or commercially available. That's where we try to increase the write band.
Okay, so I have another question. Can you give us some analysis of the complexity in the construction and encoding process of this technology? And how does the complexity scale up with the symbol size L? So mostly complexity analysis.
Yeah, so I would say that if you're just interested in setting symbol length, and if so, there are 2 steps to this, right? If you just want to verify how many bits you want to reserve, it's fairly simple. It's basically matrix reduction. So it's just as fast as you have a NumPy maximum operation. So I didn't give you an exact answer, but it's just a matrix reduction operation. With respect to an entire encoding scheme, meaning the reduction, including a choice of bits to stick between symbols. So that requires a little bit more understanding and wise choice of the bits. We don't have an analysis of how this scales with respect to L yet.
So there is another question. What is the volumetric density of data stored as DNA? So for example, in terabytes per mil.
Right. So that depends who you believe, I want to say, or what kind of technology you use. So some papers say 1 kilogram you could store the entire data that currently exists in the world. theoretically, that's true. Meaning, if you calculate how many bits or bytes fit in 1 kilogram of raw DNA, that would roughly be true. But the other question is, how do you access it, and how do you read it? So I want to say there's the theoretical density, and there's what I'd like to call the form factor, meaning what would you actually store and how would you actually store it? And that's a good question. We haven't dealt with that in the paper. That's also work that other groups are doing as well. Because at the moment it looks like you're ordering DNA from a synthesis company and you get it in a tube. So actually the form factor, or if you want, the density, will be bounded by the size of the tube. So that's not, I want to say, very high. That would be a challenge, by the way, that actually using the theoretical density of DNA.
Got it. So I think that's the last question. I don't know if you noticed there was a DNA related paper last year in HotStorage as well. So I guess we'll have this exciting technology being featured every year in HotStorage till we have commercial technologies available. Cool. Thank you, Omer. With that, we will move on to the next talk. The next talk is on libpubl, exploiting persistent user buffers as logs for write atomicity. And this is brought to you by Ji-Won Jung. He is from Sun Kwon University. The other co-authors are Jung-Sik Choi and Kwon Soo-han, also from the same university. So with that, please play the recording.
Hello everyone, thanks for attending my presentation. I'm Jae-won Jung from Sungkyunkwan University. Today I'm going to talk about libpubl, exploiting persistent user buffers as logs for write atomicity. By using non-volatile memory as the main memory, NVMe systems provide many optimization opportunities in file systems. Numerous NVMe-aware file systems exploit the performance of NVMe in their own ways. But they all need their own recovery mechanism to guarantee write atomicity in case of system failure. To improve the performance, library file system runs on POSIX file system and uses memory-mapped I/O. But memory-mapped I/O does not guarantee write atomicity. So we should provide a recovery mechanism to support write atomicity. Copy on write and logging are main techniques to guarantee write atomicity. However, copy on write causes a severe write amplification when the data is not page aligned or not the multiple of the page size. Logging also incurs the overhead by writing all updates twice, once to the log and once again to the file. We want to avoid this copy overhead by using persistent user buffers as logs. Let's see the design of libpubl. libpubl aims to minimize the write amplification. It exploits persistent user buffers as logs. By allocating user buffers in non-volatile memory regions, it can manage them as logs in a sophisticated manner. While previous logging systems intrinsically suffer from the copy overhead, libpubl can perform logging without additional write to the log. This is the main idea for libpubl. To accelerate the I/O performance, libpubl performs checkpoint on background thread away from the critical path of program execution. And the write function returns immediately after the user buffers is committed via memory fence. While providing background checkpointing, libpubl also allows application to access user buffers which are still marked as commit states log. When application accesses the user buffers in commit states, their checkpointing is changed to foreground. We call this early checkpointing. And if the buffers are already in checkpoint process by the background thread, application need to wait until the background checkpointing is done. There are two waiting cases that might increase the application execution times. To minimize such waiting situations for buffer accesses, libpubber allocates user buffers in pubber type object. We call this pubber object for short. Pubber object has multiple preliminary buffers inside, and they are internally assigned as buffers for an application in a circular fashion. Thus, in immediate use of buffer before checkpoint completion will make the pubber object switch to a new preliminary buffer. Libpubber can configure the number of preliminary buffers at its initialization. The table shows the percentage of waiting situations and performance according to the number of preliminary buffers for pubber objects. According to our experiment, the I/O performance saturates around 8 preliminary buffers, so we allocate 8 buffers for pubber objects. To guarantee write atomicity with memory mapped I/O, application needs a logging. But if application uses the logging, it should write twice in non-volatile area, so there are the performance reduction as shown in logging section of table. Even if only with foreground checkpointing, libpubber shows the same performance as without logging. Libpubber can further improve the performance by using background checkpointing. Libpubber provides scalability through a fine-grained range log using registry in multi-threaded environment. To avoid too many log acquisitions for a large size access, libpubber provides various sized log ranging from 4 KB to 2 MB, doubling the log ranges. The figure shows the performance comparison between per-file log and fine-grained range log. With per-file logs, registry searching overhead can be eliminated, but it cannot provide scalability. Only the fine-grained range logs shows a scalable performance on multi-threaded run. There are lists of metadata at the top of each memory file. Libpubber can access the log via the relative offset within the memory file. And libpubber check whether the recovery operation is needed at every library initialization time. We experimented 4 types of file system in the table. In terms of write atomicity, all file systems guarantee write atomicity in each operation except ext4dex. To evaluate performance, we used 2 types of NVM, NVDIMM and Optane. The detail of each system in the slide. The Optane memory is the 2nd generation and only Ubuntu 20.10 or higher version support its driver. But Ubuntu 20.10 is packaged with the Linux kernel 5.8 and Nova supports the Linux kernel 5.1. So our experiments for Optane system were performed except for Nova. We measured the bandwidth performance using AppIO. 4 types of file access patterns are used for our experiment: sequential read, sequential write, and random write. we enable repeatable option for all experiments. If without repeatable option, a file fills the data in a buffer once and reuses it repeatedly. Since it is not typical common workflows, we enable repeatable option. Nova requires a frequent kernel mode switches and goes through the kernel IO stack in both read and write. And read and MMIO needs to search the Redis tree to read the updated data in read, and needs one more additional memory copy for logging than readable in write. On the other hand, it only copies the data in read and exploits user buffers as log in write. So readable shows the best performance. Figure shows the performance of random write with various write sizes. For I/O on smaller than page size, Nova has overhead due to copy on write and frequent kernel mode switches. And RibNB MMIO needs one more memory copy for logging than libpub. For IOs on rather than page size, memory copying dominates as the access size grows. So libpub has fewer memory copies, so it performs faster than other file systems. Figure shows the performance of FIO for a shared file in a multi-threaded environment. Libpub begins checkpointing on background thread immediately whenever logs are available. Libpub needs a background thread for each IO thread with write permission. For this reason, in the 16-thread experiment, the number of cores is insufficient for NVDIN system, and some threads may run on the remote node for Optane system. So the performance degrades slightly. The performance of up to 8 threads, libpub shows best performance. And libpub will scale well in an environment with enough cores for writes. I will conclude my presentation. libpub is a library file system that exploits a persistent user buffer as a log to provide low latency, scalable I/O while guaranteeing write atomicity. In our experiments, it gains up to 2 times better throughput, 8 times better scalability compared to state-of-the-art NVM file system. Thanks for watching my presentation. Thank you.
Hi, Javon. Can you turn on your video and audio?
Hi.
Hi. Okay, so there are some questions in Slack. So what is the reason that libpub's performance drops when the number of threads go up? This is from Yuan Hao Chang from Academia Sinica.
libpub needs some background thread for checkpointing immediately. Can you hear?
Yeah, we can hear you.
Yeah.
Go ahead.
Yeah.
Did you hear my question? What is the reason for libpub's performance drops when the number of threads go up?
Yeah. Background checkpoint is not essential for libpub, but in libpub, in write, in both the write, sorry, I'm very nervous, sorry.
Go ahead, take your time.
since the buffer is used as parameter for write,
if you want, you can take this offline. If you want to give it some thought, you can reply in the Slack channel offline. So maybe I'll just, for the sake of time, I'll move on to the next question. Would this approach work when two processes share the same file, say read and write? And is there a way to make the user buffers visible to other processes after they are acknowledged, but before they are checkpointed? This question is from Raju Rangaswamy.
libpubl doesn't support that sharing between process. And
okay.
But libpubl provides some API public gets, so application get the contents of buffer before the checkpoint.
Okay. And then I have a question. It looks like libpubl may require extra programming effort, right? So will it be costly to have all legacy programs go through these changes? And of course, this is not just a problem with libpubl. This would apply to any new programming model, but it looks like the high cost of libpubl may prohibit such adoption. So can you talk about the potential adoption of libpubl?
Maybe some programmer when writing a new application may not be difficult to consider the buffer. Sorry, when application write to file with libpubl, it needs to invoke write with the persistent buffer as an argument. So if when writing a new application may not be difficult, but modifying an already in use application may not be easy depending on how buffer are used. So but it was easy to apply to FIO because it continuously use one buffer per thread. We performed the experiment with the Redis application, and it used only one buffer for AOF rows. So it's very easy to apply to. But some application use buffer for write and for read and for other case, then maybe it's very difficult to apply.
Okay, so there is another question from Yung Hao Chang from Academia Sinica again. Is the data consistency and crash recovery issues, are they considered in this design since the log process is skipped by your protocol? Do you want me to repeat that? Yeah. Is the data consistency and crash recovery issues, are they considered?
Yeah. If there are some system crash and the log process is skipped, then next to library initialization time, libpubl recover the log. So in initialization time, libpubl finalize IOs, so there are no problem.
Okay, so great piece of work. And I'm wondering if this is there in the open source domain so people can adopt your new programming protocol. Is this, if you make it available, I'm sure, there'll be some of the adoption challenges may get mitigated over time. So with that, I will pass it on to my co-chair, Yun Hao Chang from Academia Sinica for the next talk. Thank you very much, Jiwon.
Yeah, thank you.
Okay. So can you hear me?
Yes.
Okay, great. It's nice to have the chance to host the session. And now I'm going to introduce the third paper in our session. And the paper title is Self-Service Data Protection for Stateful Containers. And the author is the Umesh Deshpande from IBM Research, or Madam San Jose, and he's going to talk about his paper on container backups. So please play the video now. Thank you.
Hello everyone, I am Umesh Deshpande from IBM Research, and I'm going to present self-service data protection for stateful containers. This work is done in collaboration with my co-authors, Nick Link and Sangeeta Seshadri, also from IBM Research. As all of us know, the container frameworks have been gaining popularity. And as organizations are adopting container frameworks, they must also focus on preserving their data and maintaining business continuity. So if you look at the popularity of Docker images by applications, the databases like Postgres or MongoDB are among the most downloaded Docker images. Now these applications expect data protection in a similar manner as other services, like fault tolerance or load balancing. So here on the right hand side, you can see an example where user specifies the desired number of replica for their application. And the framework ensures that those many replicas are always running. So in the same mold, we want to provide data protection service where user can specify the data protection guarantees and they can be fulfilled by the framework. So when we talk about data protection, one of the important metric that is used for expressing the data protection guarantees is called Recovery Point Objective, or RPO. The RPO is said to be, say, 4 hours if the application can lose no more data than the changes made in the last 4 hours. Now, some of the challenges in providing these RPO guarantees is that the user that expresses these guarantees may not know if the infrastructure underneath, that is storage or network, is capable of fulfilling such guarantees. Also, on a shared infrastructure, the application competes with backup for resources. So if we throttle the backups to reduce their impact on the application, we prolong the backups and therefore risk RPO violation. So the challenge that we are trying to address in this paper is that how can we provide data protection to a large number of stateful applications, that is their volumes, with different RPOs while facing some of the disruptions like outages or resource fluctuations. Before going further, let me give some background about the backup process and the assumptions that we are making. So on the right hand side, you can see a stateful application using a volume. Now after the snapshot is performed, all the IOs from that application are redirected towards a new volume, and the older volume is declared as read-only. That volume serves as a snapshot. That snapshot is offloaded to the backup repository and stored there for later retrieval. This snapshot is also called as incremental snapshot because it only captures the changes since the previous snapshot. Also, it is a crash consistent snapshot because it does not require any involvement from application or file system to synchronize its state. Therefore, it can be created very quickly. Let's look at some of the existing work in the area. There are various solutions in the market like Valero, Kasten.io, or IBM Spectrum Protect Plus that provide data protection to containers. However, oftentimes, the RPOs are configured in form of a snapshot frequency. Now, if the snapshot is performed, let's say every 4 hours, that does not mean the snapshot will also be offloaded to the backup repository in that time. Therefore, in case of a failure, the application risks losing more than 4 hours worth of data. There is already an extensive research on RPO improvements on traditional platforms, either by reducing the overheads of backups or selectively prioritizing some type of applications or other type of applications. But in this paper, we specifically focus on how can we deal with various disruptions like outages or resource fluctuations in real time to comply with the RPO. Now let's look at the solution that we are proposing in this paper. We have implemented the backup system on the Kubernetes platform. So on the right-hand side, you can see a backup request in YAML format. So user can specify the backup request name, which is same as the volume name, its RPO, and the retention period, that is how long the backup will be preserved in the backup repository. So once the request is created, the user can observe its status using familiar kubectl interface. Also, the system offers resiliency against various failures by treating each operation as a transaction. So if a component fails, it is rescheduled and restarted, and the request is retried. Then finally, we rely on adaptive scheduling algorithm to comply with RPO. So that I'm going to talk about next. The insight behind adaptive scheduling is that if we reduce the interval between the snapshots, actually we get more time for copying out the data without violating RPO. So let's look at the example here. So in the diagram, you can see backups with 4-hour RPO. So in the first example, the snapshot S1 captures changes every 2 hours. So we get 2 hours of copy time. But in the second example, the snapshot X1 and X2 capture only 1 hour worth of changes. So we get an additional hour for data copying. Now how we use this insight is that when scheduler notices the backups are falling behind because of outages or resource contention, then we increase the snapshot frequency. And when the normal condition is restored, then we again reduce the snapshot frequency to whatever the minimum necessary. The trade-off that we are making here is that if we increase the snapshot frequency, we may recapture and retransfer some of the updates, and that can increase the data transfer. But with incremental snapshots, the benefit from this additional time at a critical period outweighs the drawback of temporary increase in data. This slide shows the overall process of adaptive backup scheduling. So this scheduling process consists of 2 phases: snapshot scheduling and data copy scheduling. So in snapshot scheduling, we determine if a given volume needs to be snapshotted immediately. And in data copy scheduling, we compare and pick certain snapshots for copying. Let's look at the first phase. In snapshot scheduling, the question we are trying to address is, if we need to snapshot a given volume now. We base this decision on 2 factors. The first factor, per volume slack, which indicates how much flexibility we have when considering the amount of data, the predicted bandwidth, and the RPO of a given volume. The second factor is cluster slack, which tells us how well the backups across the clusters are meeting their deadlines. A combination of these factors gives us a good sense of how quickly a snapshot must be performed for this volume. In the second phase, we pick certain snapshots based on how much parallelism we have available for data copying and the slacks of those volumes calculated in the first phase. In combination, these 2 scheduling strategies allow us to adapt quickly to any disruptions and honor volumes RPOs. Here I will show the evaluation of our scheduling strategy. We implemented the backup system on the Kubernetes platform, but we wanted to see how it would perform with a large number of requests with different RPOs. For that reason, we implemented a simulator where we could try out different bandwidth models and rate of change models. So from our observation of different workload traces, we constructed 3 rate of change models to represent uniform, bursty, and variable workloads. And also we constructed 3 bandwidth models to represent various resource outages and fluctuation scenarios in a cluster. With this simulation, we are going to compare 5 different scheduling strategies. 2 of them are fixed scheduling strategies, where snapshots are performed periodically, just with different aggressiveness, and 3 variations of adaptive scheduling strategies. 2 of them will only consider volume level information in order to schedule snapshots and backups, and 1 of them also considers cluster level information. The 2 metrics that we are going to focus on are what percentage of time was spent in RPO violation, and also how many snapshots were performed. Now let's look at the results of the evaluation. So in these graphs, you can see different bandwidth models on the x-axis and the percentage of time spent in RPO violation on the y-axis. Now we can make a couple of observations here. First, irrespective of the scheduling strategy, either fixed or adaptive, Frequent snapshotting is helpful in reducing RPO violations. This is because the snapshots are smaller, so there is always enough time left for offloading them to the backup repository. But also, where the adaptive approach outperforms the fixed scheduling is the timeliness of the snapshots. The adaptive approach is able to assess the situation and time the snapshots correctly so as to reduce the RPO violations. In this graph, we can look at the number of snapshots. We can get some sense by comparing adaptive strategy with fixed proactive strategy. Even though they perform similar number of snapshots in most cases, adaptive strategy is consistently able to reduce RPO violations. The orange box here shows the percentage difference in RPO violations. So to summarize, in this paper, we present a backup system that provides self-service data protection to stateful containers, where user need not dictate how often or when their volumes are snapshotted. It also follows transactional semantics. Therefore, it ensures continuity of jobs through various failures. It uses a scheduling strategy where it adapts the snapshot frequency according to resource fluctuations and outages and reduces RPO violations. In the future, we also want to look at the application consistent snapshots, where application synchronizes its state before a snapshot is performed. Therefore, scheduler needs to account for this additional overhead. Also, we plan to explore the applications consisting of multiple volumes that may need to be snapshotted and backed up together. So that concludes my presentation. Thanks for listening, and I'll be happy to answer if you have any questions.
Okay. Okay, very nice talk. And maybe you can also see the questions on the slide. Okay, and here's a question from Philip Chilan from Dell Technologies. And his question is that in what scenarios do you feel that adaptive scheduling is reasonable versus the customers will require fixed scheduling? Yes.
Yeah, that is true. I think in some cases it may be required to do snapshot at a specific time. So, for example, at the end of the workday, so you have sort of a periodic pattern every day, 24 hours or 12 hours. It could still be valuable, and I think we could use some approach where we nonetheless do snapshots at a given time as a constraint. But I think the point clearly stands. So there could be some other applications where they do not show such like periodic pattern, where it could be useful that you just want to provide data protection and not care about when actually the state is captured, or at least you'll be satisfied as far as the state is captured more frequently than your at least desired frequency.
Okay, thank you. Maybe the mixed scheduling is also possible, right? Okay, so the next question is from Umesh. His question is, do factors for snapshot scheduling include the rate of change in data? In other words, if the data is not changing much, can it be snapshot less frequently or meet the RPO because there's little data to replicate?
Yeah, actually, yeah, that is true. The goal is not to just increase the snapshot frequency unnecessarily, but do the snapshot in timely manner. That is only when it's necessary. So if, let's say, if we don't have a lot of data to replicate and the snapshots are small, then it makes sense to do them as less frequently as possible, because there is some overhead associated with doing snapshot in some cases. It also can increase data transfer if you do it more frequently by some degree. So you don't want to do them more frequently unless you want to. And that's what we're trying to do, which is like during the critical period, you can do them more frequently, especially with crash consistent snapshot, you have that flexibility. But you don't want to, you want to reduce the frequency whenever it's possible.
Okay. I also have some questions. For example, the first one is that does the deduplication technique consider in your design? Because the deduplication is usually used in the data center to reduce the amount of time that needs to be back up to the data center, and it will affect the amount of time to back up your data. Yes.
Right, clearly. Yeah, we haven't considered the deduplication, but I think your point is well made. That is, you have less data to replicate, and you need to be aware of how much data you have in that case. I think the snapshotting technique, some of those details the storage system may actually hide from you, which is they directly give you like, hey, this is the actual amount of data you may end up transferring, irrespective of if the deduplication exists or not. But yeah, you need to be aware of those kinds of details.
Okay. I have another question is that how to predict the network status, because it affects the completion time of the backup. And sometimes the data are not transferred to the local server. It is transferred through the network to the remote sensor, the remote data centers. And will you consider this kind of fluctuation of the data network status in the future, and how to work on that? Yeah.
Right. Yeah. Yeah. You clearly have a lot of variation if you're transferring across a cloud or over the internet to a different site, right? It's usually you want to take backups locally as well in a data center, which can be offloaded later to the cloud storage, or do you follow like synchronous or asynchronous replication model where in the background they're transferred offline? I think yeah, that needs to be considered. I think what we can do is that we can get a sense of like how from past backups, like how long they have been taking for transfer, and be conservative about it. That is, if the site is remote, then consider the variation in the data transfer time. So I think that the predicting the bandwidth is looking at like different volumes of how long it has taken for them to transfer, even if it's not the volume that is under consideration. So you can get roughly create some estimates around how long it takes to transfer, and you can get a little conservative in that sense, scheduling wise.
Okay, thank you very much. One very last question is that because you are talking about the scheduling for the the snapshot backup, and how about the recovery time? Because different kinds of backup will affect the amount of time to do the crash recovery. But if the recovery time takes too long, and then the system's offline time will be too long, and how to schedule the recovery time versus the backup overhead, because it is kind of counterwards. Yeah. Thank you.
Right. Yeah, I think recovery time is also one of the another metric that is considered. Though also it's bound by much more than the scheduling, how the snapshots are maintained, where they are maintained, and how you're going to restore them. So the snapshotting, the backup scheduling approach would not much affect that, because at the end, in some cases, the snapshot will be coalesced or into fewer snapshots, or they'll be stored in whatever form the backup repository is set up. And it will depend on the configuration of repository. Also, one of the problem in restoring the snapshot is like once you encounter failure, you often end up recovering a lot of volumes together. So you encounter that downtime because you just need to transfer that much amount of data before you start. So in some cases, like some approaches provide like an instant restore. You have a application start and then you can get the data. But the time to get all of the data out of the backup repository is still very much bound by the configuration.
Okay, thank you.
Also, it's you note that it's a user-driven process, so much control by when the restore happens on the user.
Yes, it's very interesting because these kind of two factors are counterparts, and it's very hard to balance. Yeah, Thank you very much, and thank you very much for all those excellent responses. And so thank you, and we are going to move to the next work. Thank you.
Yeah, thanks for all your questions.
Okay. Okay, now we are going to the last paper of this session, and the paper title is Row Hammer Storage Devices, and the speaker is Tao Zhang, and he is a PhD student from Oscar Lab at the University of North Carolina, Chapel Hill. His work is a joint operation together with Technion and VMware. The biggest excitement about this work is that they show the threats of row hammer attack now extend to SSD, because thanks to their surprisingly good performance, which is still keeps increasing. And SSD vendors and the cloud providers and users might need to take actions to prevent possible imminent exploits. So now, please play the video now. Thank you.
Hello everyone, my name is Tao Zhang. Here I'd like to present our work, row hammering storage devices. The work has been done in collaboration with Boris Pitmani, my advisor Don Porter, Don Zafria, and Avi Azak. In this talk, we try to explore the feasibility of row hammering the DRAM inside an SSD using just the standard storage command. The reason we do this is to try to understand whether the small embedded system within the device is vulnerable to the same row hammer attack like a big system. To warm up, we start with some DRAM concept. The DRAM is organized with multiple hierarchies, including channels, DIMMs, ranks, and banks. Inside a single bank, the DRAM cells are organized in a two-dimensional array, which is addressable by row and column numbers. Each DRAM cell acts as the capacitor, which stores bits by the charge stators. And the cell will lose charge over time, which will lead to a data loss. So they need to be refreshed in intervals, commonly every 64 milliseconds, to restore the charge status. In a row hammer attack, the attacker will try to accelerate the charge leak effect in order to induce disturbance error intentionally. To do this, the attacker picks an aggressor row, which is marked yellow in the figure, and repeatedly open and close the row at a high frequency. This will make the two adjacent rows, also called victim rows, to leak charge faster. When the charge leak is faster than the refresh rate, a bit flip may happen in one of the cells of the victim rows. This is how a common row hammer attack works. And in our work, we will use a more effective variant called double-sided row hammer, in which the attacker hammer both adjacent rows of the victim row, which can trigger a bit flip more effectively. The output of a common row hammer attack may vary, ranging from data corruption or information leak, or even privilege escalation, depending on where the bit flip happened and how the attacker exploits them. Although the DRAM vendors claim that row hammer issue has been solved, there's a varying trend that the technology node size of DRAM keeps decreasing over recent years. On one hand, this will increase the density of the DRAM so that people can get more DRAM with higher capacity or with better cost efficiency. But meanwhile, this also leads to a trend that the minimum access rate needed to row hammer keep decreasing. And the recent studies show as low as 150K access per second can trigger bit flip in newer DRAM modules. In other words, the DRAM modules are becoming more vulnerable to row hammer attack. Now, let's get back to our topic. What challenges do we face to row hammer an SSD? First, the SSD works as a black box. People have little to no knowledge about its internals. Also, the attacker won't be able to run customized rowhammer code directly inside the SSD. To solve the first challenge, we can try to pry open the black box and then reverse engineer its internals. And based on the reverse engineer result, we can try to find the indirect way to launch rowhammer workload inside SSD. So we tried to reverse engineer a popular consumer level Samsung SSD with the model name 850 EVO, as shown in the figure. We learned that this SSD actually works as a computer system itself. For example, it has a 3-core Cortex-R4 ARM CPU and 512 megabytes of LPDDR3 DRAM, and it provides 120 gigabytes of non-flash storage. And then we try to learn how the DRAM on this SSD is being used. The DRAM is used to store the FTL runtime code and data, and it also provides a buffer for incoming I/O command. And also it has a logical to physical mapping table, which is also called L2P table, to translate the logical address, the LBAs, to physical addresses inside the non-flash. The L2P table is commonly organized as a linear table or hash table. And also we observed that the DRAM accesses inside this SSD is not cached. So we learned about some internals. Can we rowhammer the DRAM inside this SSD? It looks like the L2P table is an interesting spot to start with. Here we take a closer look at the L2P table. We use a linear table layout as an example, which is essentially a linear array indexed by the LBA. When a host read request comes in, the LBA will be used to index into the L2P table to translate into physical block address. Then the corresponding physical block will be read and returned to host. So it looks like we found a solution for the second challenge as well, in which the attacker can make use of normal read requests to trigger accesses to different regions in the L2P table. Based on the observations we have for now, we propose a rowhammer attack on the L2P table. To make it easier to understand, we assume a range of L2P table entries are located across 3 consecutive rows as shown in the figure. And then the attacker sends a sequence of read requests with carefully chosen LBAs so that the corresponding L2P entries alternatively fall into the 2 side rows, just like in the double-sided rowhammer attack. Thus, the middle row, as the victim row, will have bit flip in one of the L2P entries. The bit flip will cause the L2P mapping being redirected from the original physical block to a different one. To justify the possibility of such attack, we note that latest PCIe Gen 4 SSD can provide around 1.5 million IOPS compared to the minimum access rate to trigger bit flip we mentioned earlier, which is as low as 150K access per second. So this is truly raising a red alert to people. Now we have a bit flip inside the SSD DRAM. Should we expect the same outcome as the host side rowhammer attack? First, we expect the data corruption is still the most straightforward outcome. But as for the information leak and privilege escalation, exploit for host side rowhammer attack would not work here. So we need to develop new exploit for SSD rowhammer attack. Here we take information leak attack as an example. We will target the ext4 file system, which is widely used among Linux systems. The ext4 file system supports a legacy direct-indirect block addressing mechanism in which the inode can contain direct pointer to data blocks as well as pointer to indirect block, which itself store pointer to data block. Note that the indirect block is not protected by any checksum, which leaves it easily exploitable. So the attacker can construct the data block to mimic the structure of an indirect block. Normally, this fake indirect block won't cause any damage. Next, we show how we turn it into a data leak attack. Here, the attacker creates a file with an indirect block pointing to a data block mimicking the indirect block, and contains the LBA to a data block C. Note that on SSD, there's an additional layer of indirection where the LBA need to be translated by the L2P table to point to actual physical block. And now, the attacker can launch rowhammer attack on the L2P entry for the original indirect block and cause it to be redirected to the fake indirect block. And thus, the attacker own file will now follow this fake indirect block to access data block C, which the attacker originally has no access permission. By this, we turn the bit flip inside SSD DRAM into a data leak attack. In conclusion, we have shown that the threat of rowhammer attack are extended to a new dimension, the storage devices. But there are still many open problems. For example, can we apply other host side attack on SSD as well? And as for mitigations, we discussed some possible solutions in the paper, but there's still some unexplored space. And do we have a more principled solution for similar threats instead of doing the attacker and the defense game over and over again? Thank you for listening.
Okay. So for the audience, if you have questions, you can post your question on the Slack. And Tao, you can also look at the Slack if there's any questions. Okay, now I have several questions to your talk. And this is very interesting work because this is my first time that I can find that the rowhammer can be adapted to SSD DRAM. But the first question is that when we want to have the rowhammer to let an LP table entry pointing to block A and then redirected to pointing to block B, but how to precisely control that the L2P entry will be flipped to exactly the block that you want? Okay, thank you.
That's a good question. So actually, in the bit flip, when the bit flip happens, normally it happens like by changing the 1 bit inside the physical address from 1 to 0. So actually, essentially, you need to design the layout of the L2P table so that usually it changes from a high address to a lower address. So this happens in mostly a more random way. So mostly we just do that over and over again to get a meaningful output. But essentially, the attacker might have little control on this, but since the attacker can do this over and over again, then to do the trial and fail like experiment, eventually, so we expect the attacker will get a meaningful outcome like eventually. Yeah.
Yeah. Okay. Very interesting. Yeah. It needs a lot of engineering effort, and because there's one question from Golf Cooling and from Harvard Medical College, College. And he said that the attack you presented requires knowledge the layout of the EST4 blocks as well as the layout of the SSD. Is it possible to discover those things? Do you currently do have a sample for it that works? Yeah.
Yeah, good question. So for EX4 layout, since it's open source, so the attacker can actually study the EX4 layout details just from the source code inside the Linux kernel. And as for the actual physical device on the disk, the attacker, so in our paper, we have a more detailed discussion. Let me briefing the technique here. Essentially, the attacker needs to spray the file system, EX4 file system. Since we already know the behavior of EX4, so the attacker can make use of some behaviors of EX4 to spray the file system to create as many as possible the fabricated indirect block inside the file system. As for the SSD internals, that's really the biggest challenge for the attacker. Since mostly the SSD vendors keep the FTL as a secret source for like a commercial secret or something else, the attacker do need to have either reverse engineering technologies to pry open the SSD and to peek into the secret. So in our case, we started the commodity level, the consumer level SSDs, Samsung 850 Evo, and we learned that we are pretty lucky that this SSD has a debug interface, which allows the developer to attach to the SSD via JTAG. But I'm not sure if that's common for the newer devices, like the newer NVMe devices. So that might be an interesting future direction to look at. Another thing, and our attack is based on emulated SSD. We experimented on a host side system, which we have details in the paper. The biggest problem is the SSD weight reverse engineer doesn't have a fast enough access rate. So we don't have a working on real SSD yet, but I think that's possible in the near future.
Okay, and another question from Brian Kim from Syracuse University. His question is, SSD typically writes the LBA information together with the data in the physical page. Should this be used to check if the mapping table has been row hammered? That is, if the mapping entry has been corrupted. The incorrect physical page shouldn't point back to the original LBA. Does your experiment indicate that the current flash repath doesn't perform this check? Yeah.
Yeah, good question. So actually, so the SSD weight reverse engineered, it does make the L2P table permanent on the NAND flash, like since you don't want to lose that information between reboot. But to increase the access rate, normally the SSD will cache buffer the whole L2P table or a portion of the L2P table inside the DRAM on the SSD. So in that case, it will. In that case, the SSD can save the visit to the NAND flash on each I/O request to increase the IR of the device. But this highly depends on the FTL behavior, so it might vary between SSD to SSD. So at least on the SSD we reverse engineer, it doesn't access the NAND flash to access the. And another thing to note is we don't rely on a permanent redirection to the L2P table. We just need a temporary redirection in the L2P table to get a temporary access to the data block for the sensitive information.
Okay, thank you. And we have the last question from Jason Liu. His question is, while you showed the potential of the roll hammer attack, is there any empirical evidence that such information leakage may happen in your experiment?
So we actually, we actually have a proof of concept attack which worked in our experiment, but as I said earlier, we don't have any evidence this is happening in actual, like in the wild, in the cloud provider or something like that yet. But like the talk shows, like since we are having faster and faster access rate for the new coming SSDs, so we expect this might be possible. At least people need to be take precautions when they are using cloud services.
Okay, the time's up. Actually, there's one more question. Can you give us a short answer about the question from David Iduk from Avid Technology? His question is, how do you know the internal structure of the various L2P tables? Because this is a vendor-specific logic.
Yeah. That's so it really relies the attacker need to have the ability to reverse engineer the SSD actually. So in the worst case, with the SSD that is fast enough, the attacker, we speculate the attacker can also just randomly pick like a pair of LBA addresses and to repeatedly like access them at a high rate to hope in the hope that to trigger a bit flip somewhere in the SSD, maybe not in the L2B table, just to make it kind of like a denial of service attack in that case.
Yeah, sure. Okay, thank you very much, Tao, and thank you to bring us such a very interesting research results. And thank you. And now we have this session end now, and we will have a break now, and then please come back for the next session. Okay, see you. Bye-bye.
Hello.
Hi.
Hi.
Hey, Phil.
Hi, Niraj. Hi, Shunjin. Hugo, hello.
Good morning.
It says that I can't start my video because the host has stopped it.
We'll fix that in a moment. Thank you. All right, great. We have everyone. Thank you for joining us. Thanks to our panelists for agreeing. Many of you very readily agreed to help support HotStorage and join our panel. And I look forward to our session today. Thank you. Our topic is From Ideas to Products, the Path of Successful Storage Startups. So we have 4 founders with us today. Besides founding, they have had many important roles with their companies. I'll briefly mention a few things, but they probably have had many hats within their companies. And I have a few questions to get the discussion going, but also there was a Slack channel, and so I welcome the audience to post their questions to Slack. I'll try to intermix those into the session. So just very briefly, we have Shunjun Park, CEO and co-founder of Catalog, Hugo Patterson, CTO and perhaps other roles, and co-founder of Datrium, Niraj Tolia, President, GM, co-founder of Kasten, Hakeem Weatherspoon, CEO and co-founder of Exotanium, and associate professor at Cornell University. So perhaps we'll just go around the group and I'll give each panelist a chance to briefly introduce themselves and tell a little bit about their company. We'll try to keep it to a few minutes each. And perhaps for this first question, we'll just go in alphabetical order, starting with Shunjun Park, please.
Great, thank you. My name is Hyunjun Park. I'm the co-founder and CEO of Catalog. And so we're a company that's developing synthetic DNA molecules as a new medium for data storage as well as computation. So we began with the company a few years ago with the idea of encoding lots of information in a cheap and easy way into these synthetic DNA molecules. And we saw this as a long-term storage medium. But as we develop the technology, we're seeing more and more possibility of computing directly on these molecules without having to pull the data back out into an in silico medium. So we're in early stages, very exciting times for the company, and very excited to see where the technology can take us.
All right, thank you. And Hugo, could you go next, please?
Sure. So most recently, I was at Datrium, as you mentioned, a number of different roles, actually ended as chief scientist there. Datrium was actually acquired by VMware just about a year ago, and I left Datrium at that time. But we had set out to integrate both very high performance and built-in data management storage system focused primarily on VMware environments. And so really combine some of the storage efficiencies of a data domain with the very high performance of a flash storage to really put the two together in an affordable but high performance system. This turned out to be a very natural fit for disaster recovery, and the product that VMware is still selling derived from this technology is disaster recovery as a service. It replicates data from an on-premise to the cloud or potentially cloud to cloud, and is able to store it efficiently in the cloud, but then restart workloads in the cloud and run them without having to reinflate or restore all of the data. So that makes that whole process of failover to the cloud much faster and more efficient.
Okay, thank you. And Niraj, could you go next, please?
Sure. Hey, everyone. So I'm Niraj Tolia. Till recently, I was a co-founder and CEO of Kasten. We got acquired by Veeam roughly 10 months ago. So great exit, can't complain about that one. And we used to do and still do backup for containers. So when you think Kubernetes running in many environments, how do you back that up? Right. So underneath the hood, storage, deduplication, a lot of common themes in the last startup that actually have followed me through my career. But before this, I spent a couple of years at EMC, like Hugo did, again, another acquisition as VP of Engineering, Chief Architect at this other startup called Imaginetics. We did distributed file systems, got acquired by EMC, right? Worked on some of the products. Hugo also intersected with data domain networker, supporting their on-ramp to the cloud. Along the way, I was a technical advisor to another storage startup called Hedwig that did distributed block storage, got acquired by Commvault a few years ago. And right, so I've been working both small company startups as well as large companies over the years. And right, if you roll back the clock, spent a couple of years doing industrial research at HP Lab, and before that was a part of the parallel data lab at CMU, where I got my PhD from, also got my undergrad from there.
All right, thank you. And Hakeem?
Thank you, Philip. Yeah, my name is Hakeem Weatherspoon, and I'm the CEO and co-founder of Exotanium. Exotanium is a cloud optimization company. So the short of what we do is help you save lots of money using the cloud. It's one of the focus of what we do is help stateful applications. So think databases and whatnot, long-running simulations, data-driven applications, AI applications save lots using the cloud, about 2/3, 3/4 of the price. This came from research. So I'm a professor at Cornell University. We have a research project from 10 years ago, one called Zen Blanket. This allows you to do nested virtualization in the cloud, and as a result allows you to migrate from one cloud provider to another, Amazon to Google to Microsoft. It was followed on by another project called the Super Cloud, which then added to that orchestration, storage, networking, and also the VM. So you're able to migrate while maintaining not just the same IP addresses, but the same network connections. And so we're able to, for example, as a company, use the spot market to essentially maintain a highly reliable application while reducing the costs 75 to 90%. I've been at Cornell for 15 years. In fact, I know Niraj from when we were students. I was at Berkeley, he was at CMU, and my home is really fast, file and storage technologies, and I chaired this workshop, Hot Storage, about 10 years ago or so as well. So my roots are in storage.
Thank you. Thanks to everyone. So clearly, you all have a kind of entrepreneurial spirit, and so just for the audience, would probably be interested in what motivated you to start the companies you're associated with, and in some cases you've started or influenced multiple companies. Can you just talk about why you got into that area of entrepreneurship? And I'll just kind of open it up to the panel as a whole.
Sure, let me take one of that, right? So what I've seen in terms of, right, both what I founded as well as other companies generally comes from real world problems you run into. Sometimes it's personally, right? Caston, it started off because at EMC, we were trying to do something with Kubernetes. We were in the data protection group, couldn't protect our own products, right? And we knew this space would take off. So it's combining some of those first principles we use in research to see where the world is going to go, and figuring out unmet problems generally and itch you're trying to scratch, right? There's obviously a lot of research goes into this too, in terms of looking at customers and seeing, is this a real problem? Validating a lot of this even before you get into really building out what you're thinking of. But it's generally you're looking for a hard problem to go tackle versus having a solution that you try to figure out, how do you go apply that? So there's the question of what a company would do. I think for me, though, before even that was just a desire, I thought that that it would be a fun kind of career to be an entrepreneur. From when I was a teenager, somehow I had this idea that that's what I wanted to do. Back then, I actually thought it would be in robotics for manufacturing. various events led me to storage instead. But I always had in mind the idea that you could have a more tangible impact for potentially for the good on the world by actually building something new and bringing it to market. And the potential to have that impact, positive impact for the customers, solve a problem that they have, and also to build a environment where employees, they all spend a large part of their lives working, and it's much better if that can be a very positive experience as well. And so you're really the potential to have a positive impact, I think, seems greatest in that with that path, and that's really what attracted me to it in the first place. To make that, viable and meaningful, of course, you have to find something that that does solve a customer problem, or else you're not really going to be in business, and you're not really going to have a company. You're not going to have a lot of employees. You're not going to have customers. So, you really need that whole package.
Yeah, and I would add to that that my interest in entrepreneurship stems from research. There's a lot of successful companies that have started from research, and the key is that when you're doing a research, a PhD is essentially, by definition, you're doing something new, something that nobody has done before. And like Hugo said, unless you can find a customer, so that's that connection, won't be viable. So I've always been interested in taking what I've done in research and improving it out in the marketplace. I'll just note some companies, for example. So Amazon itself, they downloaded Zen, which is a research project in order to virtualize machines. Databricks, is another company that's doing quite well. VMware, from Disco operating system in the 1990s. So there's a lot of precedents of taking research artifacts and then seeing if you can actually prove that out in the marketplace. In our case, we actually had, it was a multi-cloud, so we wanted to break vendor lock-in. We also thought we had something that was a security solution. So the exo kernels, and also exoskeleton and titanium. So it's supposed to be a strong outer shell to protect what was inside. So we thought we were a security company. And so I was just kind of laughing to myself, because what Hugo said is that you have to have a customer. And so what we realized is that security, of course, is very, very important, but everybody was jumping up and down screaming that they're not happy with their cloud bills at the end of the month. And we actually realized we had a solution for that. So in any case, connecting the research to the practice in the marketplace is essential.
I think I share everything that the other panelists have said about their motivations behind starting a company, solving the hard problems and having positive impacts with your research. For me, the most relevant question here, though, was whether to do that inside the confines of academia or to go out and start my own company. And the thing that influenced me the most was where I wanted to be in this life cycle of technology, of the value chain. You could be researching things in the lab inside the university where you're creating extremely exciting technology, but be very far away from the customer and product. Or you could take one of those ideas and start a company around it and start to create a market and interact with customers and really see the impact of that technology firsthand. And for me, I thought that end of the spectrum was more exciting for me. And another thing was, as kind of Professor Weatherspoon alluded to, the currency in business is the customers and the market. But sometimes in academia, the more relevant currency is articles and new inventions. And I thought of the two, what's more exciting for me personally And so starting a company for me was, I think, more exciting idea, more exciting prospect for me.
Well, I want to follow up on a couple of points that several people raised. So how did you identify these customer problems? Were these problems that you personally saw from your previous experiences? Was a lot of market research? Did you have partners that identified problems and customers? Can you just talk a little bit about that process? I think people in the audience who might be considering companies as students kind of wonder, how do you make that step to find the customer problems?
Maybe I'll start out and talk about our experience. So we did what's called a National Science Foundation Small Business Innovation Research Grant. So this is something that can help transition from research to business. And one of the things that they require is that you do a customer discovery, because they know that most people are good at the science, but not necessarily the business. And so you have to ensure that you have that business case, that customer need. And so we end up doing what's called a national ICOR. So they require you to talk to 100 customers. This was before COVID, so we'd actually have to fly. And that was what the funding was for, to fly and actually talk to people in person. And it wasn't until about the 90th customer for us. So I don't know if 100 is a magic number, but well, I said we initially thought we were security. But when we were talking to people, it was about the 90th that we realized that we were hearing a theme on that, there was a low satisfaction, high priority area. And so once you identify that, and if you have a solution for it, then that can be key. So at that 90th interview, we took a look back and we saw that, over half the people were unhappy that they're spending so much amount of money. This was pre-COVID on their AWS or Azure bill or whatnot. And they're screaming for ways to, to reduce that somehow. And with this migration technique, like I was talking to you about, which is not the thing we're looking at, it's kind of a VMware vMotion in the cloud. We're able to reduce costs significantly. So in any case, we actually pivoted at that point. We had submitted and were awarded the SBIR, and we actually ended up changing directions and creating a MVP in this other direction, and then getting another award for that. So that was interesting for us. I think any company ends up pivoting some number of times, but you can't do that unless you're talking to customers.
So I completely agree. It comes from talking with customers. And so, for example, with the data domain experience, this was actually before I joined, but they thought they were going to use big fat disk drives, which were kind of a new resource to build on. They were going to use them for archiving. And so they started talking to a lot of customers about archiving and how great it would be to archive on disk instead of tape and so forth. And the original first inventions were about, spinning disks down to save power in your archive and so forth. But the more they talked to customers, they realized that actually they were willing to talk about archive, but somehow the conversation would always go back to backup and how painful that was. And so data domain, switched to focus on backup instead of archiving.
I guess
that was a much more significant customer problem.
I'm hearing that talking to customers obviously is important, and I guess it's a little bit of a mystery perhaps for some of us. Like, how do you find those customers? How is it personal connections? Are there resources to help you? I mean, it's hard to cold call a company and say I want to talk to somebody. So how are you doing that?
Well, you say it's hard to cold call a company, but that's exactly what you do. In fact, we ended up both Data Domain and Datrium, we hired people whose job was to cold call companies and find the right people in those companies to talk to, and then set up conversations. So yes, it's a little, it can help if you have, can use your network of connections to find people to talk to, for sure. But there's also a bunch of just cold calling involved.
Yeah, and what I have been shocked by every time we've started something new is the number of people that are willing to help, right? Especially when you're new. Communities like FAST and HotStorage, when you go look at attendees, there'll be a number of people from industry. People can go mine that. But alumni networks, people right? People who right? Your advisor, you don't leave any resource untapped. And some of these meetings will be complete misses, but that's all a part and parcel of the journey. But every time I have personally done stuff, the people that come out of the woodwork to help without expecting anything in return has been unbelievable, right? And all I've been able to try and do is see how I can pay it forward. But I think there's going to be a lot more people to go help when you go start looking for it. Right, but Phil, also to go to your original question, right, we've talked a lot about customers, but something that I think it took me a few years to learn is when we go startup, especially from the research side of things, is I think I see two different kinds of markets, right? There is the traditional market, like, block storage existed for a while, but then someone said, let's go replace disks with flash. So you have new technologies and new ways of fundamentally improving the process, faster, cheaper, more reliable, etc. But then you also have this category of startups that are in the emerging markets, right? When we started Kasten, there weren't too many people using Kubernetes to begin with. So therefore, the customer pool was very limited. And you go ask those questions, especially people coming from research that are at the cutting edge of things, right? I honestly today seen so many startups doing things that research papers got published on a decade ago, right? So coming out of that point of view, right, sometimes for an emerging market or emerging ecosystem, finding customers might be hard. And that's where some of the things we've learned based on first principles and making educated bets can also help, combined with trying to find the bleeding edge adopters, which can be somewhat harder to
On
find.
customer discovery, I would just add that, I don't think we should discount serendipity, especially around events like this. Where you're taking part in events, you're presenting your ideas and taking part in panels, and that gets exposure to many relevant people that you may not have even thought of. And you may not even have to go out and cold call everyone because they might be taking interest in your technology and reaching out to you. And for us, that's actually been the case for all of our customers. We've been very fortunate not to have to go out and do the outreach, but to get enough inbound interest to be able to form great relationships with great customers. So that, and then going back to your original question of customer discovery and product market fit, it's interesting. We also started out thinking that DNA would just be a cold storage medium for archival storage. So you would put everything into DNA so that you can store lots of information in a very small volume and keep it around for thousands of years if necessary. But as we were talking with our customers that we've been able to develop over the years, that prospect of storing information for a long time is very important and will always exist. But it's not as exciting as if you were able to store all that information, and also be able to compute on it directly in a highly parallel fashion in this new medium. So we've kind of pivoted towards that idea of DNA-based computation. And so what I'd like to point out is, again, to reemphasize how important it is to develop technology towards a need and in close connection with your customers, rather than to develop the technology, figure out a solution and then go out and look for a problem that fits that solution.
Thank you to everyone. I think, Shunjan, that the audience we have today is probably not as familiar with DNA storage as perhaps some of the other topics. And so, could you kind of briefly just tell us, what are the storage areas where you think it's a good fit? Maybe something about the customers you feel that you can serve the best.
Right. So traditionally, the thinking around DNA has been that because of longer read and write times going in and out of this medium, what you'd want to do with this technology is store things that are in the lowest tier of storage, the coldest tier, where You want to keep it around for or indefinitely, but not necessarily have to go through it very frequently, if ever. But all organisms, including everyone on this panel, are examples of highly parallel DNA-based computers. And so what we're doing now is seeing what we can take from biology, all the tools of molecular biology that have been developed over the last 50 years, and as well as all the enzymes and mechanisms that have biologically been evolved to function inside of organisms over billions of years of evolution, to see how we can manipulate the DNA that's containing digital information using enzymes again. So it'd be in a highly parallel fashion. You'd be addressing all of the bits that you have stored simultaneously, and then seeing what applications, if you had that ability, what that could help. And so what we've discovered in conjunction with our customers is things like pattern matching, searching, and copying are very easy functions to do in DNA form. I mean, COVID testing is something that everybody's familiar with right now. That's an example of a highly parallel search in a very short amount of time through a really large database. But we can extend that to things like pattern matching for machine learning algorithms. If you've trained an algorithm on a smaller set, and now you're wanting to do inference across an exabyte of data, and you want to do that in a very short amount of time in a highly cost-effective manner, this might be something you could do in DNA. Or also things like database comparisons. If a large company acquires a smaller company, they want to compare the customer databases of both. See compare and contrast, what are the commonalities, what are the differences. This might be something that you could do very efficiently in DNA form. I'm just listing a couple of different applications, but we're still in the early stages, and but we're seeing a lot of interest from potential customers in developing this technology with us.
All right, thank you. So we have some questions in Slack. I think I'm going to kind of merge two of the questions that are about pivoting, because I think a couple panelists mentioned that the company has perhaps pivoted a little bit from the original plan. And so some of the questions around that are, what are the challenges, and what's the success rate for making a major change? But then also related to that, how did you actually make that pivot? Did you have to adjust your hiring strategy? Were there just internal technology things that helped you or hindered you? Was it different hardware you had to buy, different cloud computing resources? And what were the practical steps involved in pivoting?
Yeah, maybe I'll start. And also connect this with the prior question a little bit. In terms of the customer discovery, we did a lot with introductions. So as soon as we got 3 introductions, then we would ask each one of those people to introduce us to 1 or 2 more people. So it actually could start out quite small, and for us, it did start small, but you had this exponential growth because people were willing to help and they were willing to introduce you to another person. And the success rate of a warm introduction, I don't know, it's like an order of magnitude higher than a cold intro or call. When we pivoted, so this was for us 2019. We did this I-Core, like I said, through the summer. And then it was about September or going into October that we realized, hey, we need to pivot to another direction. So this is 2019. And so then November to February, we then started to create this MVP in this other direction to demonstrate that we could reduce costs of using the cloud using essentially a live migration. So we're able to demonstrate that in February of 2020. So we all know what happened in March of 2020, the pandemic hit. This was significant for us because we were going to use essentially this MVP to raise money on. And so we hit a tough time. We didn't have to let anybody go. We were about 5 to 6 people at that time. But we filed for what's called a payment protection plan. So we actually got that. And we were raising money starting in March, really, of 2020. But because the message resonated during the pandemic for us, if you're spending 50% of your revenue, people now are spending, 2/3 of the revenue on the cloud. It was just skyrocketing. And so we're actually able to raise twice as much as we set out between March and June of 2020. So it was I would say it was something that was not easy, but when you talk to the many different customers, which I would say is required to really figure out what the customer market fit is, then you realize that you really have to go in that other direction. Or sometimes you realize perhaps this is not the right time for that business. That's actually a perfectly good outcome if you realize early, felt early in some sense, or pivot. So there's nothing wrong with it. It's actually a very good thing to do. I don't know how many times a company may do that, in its lifetime. But early on with 6 people, it's no less challenging, but required, I would say.
Certainly it is more difficult later. The pivot in data domain from archiving to backup happened really even before the Series A founded. It wasn't really a company yet, so that was relatively straightforward. Datrium, in a sense, pivoted from selling on-prem appliances to selling, cloud services, selling disaster recovery as a service. A lot of the core technology lines of code leveraged, but a much more significant shift in the business focus, the operations, how pricing works from, so just many changes, and certainly required different kinds of people. And so that was much more of a project later in the stage of the company. But you have to go where the customers want you to go, or where there are customers. So it's not really a choice in the sense.
I would echo that it's not an easy effort, and there are a lot of different things to consider. I would say that for us, at least, the most important thing to think about first and solve for was the internal conviction and the alignment of the team in this new direction. So there are other things to think about, like investors and new hires and new machinery that's required. I think all of that can follow once first of all, the leader of the team, and then the leadership of the team, and then all the way down to every single employee of the company really believing and being convinced that this is the right direction for the company, I think is the most important. And then once you have that, then the rest will not easily, but follow.
Yeah, something I'll just add on, somewhat of a counterpoint, right? There is a risk to pivoting too much, especially as a first-time founder. Right? There's a recent study done that said when you look at large financial outcomes of startups, the larger ones tend to happen where there has been far less pivoting compared to the original vision, right? During the first 6 months, year of a company or pre-incorporation, I think there's a lot of research involved. But then you need conviction, you need knowledge of the space you're working in, that you have that belief that the problem you're working on is the right problem to work on. And then trying to pivot to something else, because the grass will always be greener on the other side, right? There's some company raising $200 million with a 5% team, right? Ridiculous things like that. And you'll say, oh, maybe that area is more attractive. I can do something there. Maybe I can leverage 50% of my code, right? But generally having, and data shows, right, that having conviction in the area you started in, having belief there that is validated, will generally, right, statistically lead to a better outcome than trying to pivot, every year or so.
Raise another question from Slack. This is from Umesh Mashwari. What is the scope for starting a new storage company given the massive migration of workloads from enterprise data centers into hyperscale clouds, where the hyperscale vendors have developed custom storage stacks and generally quite good ones? I can see some scope for new companies in the area of backup to the cloud. All that's already a crowded space. Are there other areas? So I guess kind of summarizing that, when you're trying to create a new storage company, there are these hyperscalers that already offer quite a lot of functionality. And so what are your challenges and how do you kind of fit into that space?
All right, so let me start off with that one because I briefly replied to Meshan's slide too. So in short, doing core storage in the cloud, 9 times out of 10 is going to be a losing proposition. There are too many failed startups. The space is littered with people trying to say, look, I want to compete with AWS's EBS, which is a block storage solution, as an example, right? I want to do object when I have AWS S3, which is not to say there isn't space to innovate, right? When I go look at the audience here, when I go look at the skills of the people here, it generally is in some form of verticalization, right? When I go look at database companies today, right, distributed database companies, you go look, peek under the stack, a lot of it is storage technology. When you go look at Hakeem's startup, right, he's saying cost management. But a lot of his secret sauce is, how do you do this with stateful applications? We did it by saying, look, here is backup for containers, emerging field. All backup solutions don't work, but underneath the hood, we're really a storage thing. I built out my third dedupe engine here. So I think it is about what you work on and the skills applied are different from how you might show this or how this shows up in the market, right? And I think there's still a rich space where you're innovating underneath the application above core storage, right, in public clouds, which is a lot of where also the new spend is. It's easier to break into a public cloud market than an on-prem market. We can talk about the reasons why. So if you're doing a startup, it makes sense to focus there. But how you do it, I don't think you'll do it from, I'm going to offer a 10% better block storage solution. Right? So at least that's my 2 cents on it.
Yeah, I think competitive advantages would be something that's one of the most important things to think about. You might be surprised, but even in the field of DNA-based storage, there are several competitors out there or other groups that are working on DNA-based storage. There are large companies. There's even a DNA storage alliance. So before we started the company, we thought about why start the company in this space where large companies with much deeper pockets are already in. And so, are you going to be 10% better? And I think investors like to throw around numbers like the rule of thumb is if a new technology isn't 10 times cheaper or 10 times better, then it'll never be adopted by customers. And so I think you got to be really honest and go back to the drawing board and see if your technology ever has the chance of being that much or even much more cheaper, faster, or better in some other metric than what already exists. And if you have a firm answer for that, then maybe you're starting to build the case for why you would build a company in this space that other people are already in.
Yeah, I think that's a good point. But to Umesh's question, yeah, I think the market for on-prem appliances is not a rich one at this point. But I think may there be other opportunities. I think it's always dangerous to say, well, there's no opportunity there, and the next thing you know, somebody has figured something out and offered new capabilities that are highly desired, solve important problems for customers. So.
All right, so I'm going to take a question that Vasily Tarasov posted. He's asking, can you share some memorable mistakes you made in the course of building your companies? I'm also going to merge it with my own question. Can you talk a little bit about some of the important milestones your company went through at various stages that you thought were kind of key? And perhaps we can mix in, some memorable mistakes as you were reaching those milestones.
So many mistakes to talk about, right? But every time you go do it again and you hopefully make a different set of mistakes. But it's part and parcel of just how things work. But I think, talking about milestones, right? Obviously, once you've said you're going to do a startup, and in particular, non-bootstrapped or VC-funded startup, right? Know what you've signed yourself up for, right? Be aware that that comes with different pressures, different expectations, and that incent our outlooks aren't aligned, right? You as a startup founder, right? In your career, you might do 3, 4 startups. An investor is going to invest in 50, 100, 200 companies, depending on the size of their checkbook. And so they want companies to go big or go home. So make sure incentives are aligned with your investors. Picking the right set of investors will make a very big difference, right? And once you go into that, once you raise the seed round, raise the A, B, whatever it might be, we figure out the right benchmarks you need to hit and be honest with yourself. Can you hit it? Is the company at that stage? Are you going to go raise that amount of money? Can you put it to work? Can you get the valuation you want of where your company is? Being honest with yourself is going to be very big, right? For us, this is somewhat sad, but at Casson, one of the mistakes I made was not spending money fast enough, right? And we're a software company, so it was all about people spend. And this also ties a little bit into Eric's question, what are the skills one might need? But I think, me being a technologist at heart, the many hard lessons I learned about ramping up what people call go-to-market early. And there's so many things I do all differently this time around. But I think I should have invested more dollars into marketing and sales earlier. When we started putting it in, it started having an immediate payoff, which means we were a little too late in the game, right, for that. Ultimately, things still worked out, but in retrospect, right, the writing was on the wall. We should have done that sooner. So at least, that's one recent thing I'll talk about where it sounds counterintuitive. Shouldn't I be conservative with cash? But no, that's what I signed up for. And I should have deployed that more effectively for the company compared to what we did. And then, how we fixed that also.
Yeah, key milestones in development occur along a couple of different dimensions, right? One is the intersection of a technical solution with the customer problem. So there needs to be customer validation. We've talked about talking to a lot of customers. If you haven't passed that, then you really shouldn't start pouring a lot of money into it and effort. But the next is really the ability to recruit in key players. If your team doesn't have already people to own and drive the different areas that the company needs, and part of that is, might be software development, might be hardware development, but it is also sales, it's also marketing, might be operations, depending what you're doing, customer support. All of these are important areas, and some of those hires, depending on what the company is, do you have the core, does the team have the capabilities it needs to get done what it needs to do? So key hires can also be an important milestone at the beginning. And so, and investors look for that as well. Is this founder someone who can attract key team members to them, right? It's not just, is the idea good? The question is, can you execute on it? And so demonstrating to investors, but to yourself and as well, that you can make progress. The idea is good enough to attract the talent you need, good enough to motivate customers to actually write checks for it, and so forth, are all important milestones. These were mostly here, we're talking about tech startups, and so there needs to be some tech content. Does it work? Have you solved the technical problems, or does the thing just kind of, is there more to do there? If there isn't some kind of reasonable technology in it, then you don't really have a defensible project. That someone else can just repeat it with a deeper pockets and more access to customers. And so also that will, investors will tend to shy away from that. So,
and just as a brief aside, in terms of what Hugo said about team, folks, look around you, right? The people in this community that could be a startup founder is people you're going to take with you, right? The people from FOST right now, or people in the systems community that have been working with me now for the last 15 years across 5 or 6 companies, right? And we keep on doing this. And these are people that have published, and these are people that have said, okay, I'm going to go do the startup thing now, right? For a number of reasons the panel's talked about. But you'd be surprised, and I was initially, right, at the people around you that sometimes want to do different, right? Yungjun talked about making an impact that is outside of academia, that is outside of the writing papers. So there are folks around you that could be partners on this journey. So, right, don't think that you have to go out somewhere else to find the right set of people to go do this with you.
Yeah, and actually just riff on that a little bit. The team is critical, especially initially, because those first months or a year or so, where you're trying to figure out what your actual technical advantage, but what your actual direction and fit is critical, and who you have as part of the team, and then the commitment levels of people. So for us, we were 3 academics. Initially, myself, Robert Veronese, and our former student, Ziming Shen. Robert and I are professors, but I'm on a sabbatical and leave of absence. He's still a professor. Well, we're still professors, but essentially 1 day a week. And so early on, we got the advice, which was critical, which is, go out to dinner and figure out what the commitment level is of the people, and come up with something that then makes sense. And then as you're growing that team over time, the personal aspect is really key as well. You got to get along. We had some early lessons there, where we had somebody who's more business, which is fine, but it was just a little bit of a mismatch early on. Might have been a little bit too early for us. So timing for some of the team members is critical as well.
Yeah, I think all the most important milestones have already been mentioned, across different dimensions like funding, technical development, hires. I think that none of these are orthogonal to each other. They're intimately linked. If these are the right hires, then are necessarily important to the technical development that you're hoping to achieve, and hopefully sufficient for it. And that gets you to plateaus where you can expect to get the next valuation that you'd like to have for the next funding round, and so on. And so I think in going through those, what I realized was perhaps similar to what Niraj had mentioned. Even if you're a very technically focused startup that's going to focus on the achievements, the performance metrics of your technology, I would almost say it's never too early to start getting the word out there for people to know about you. To start early on the PR and participating in events, presentations, not be worried too much about exposing yourself and hiding yourself from potential competitors, and as long as you're not putting out confidential information out there. And that's because that aspect of it just helps you in every part of your life as an entrepreneur. If people have heard about you before, they're more likely to accept your call, or an investor might reach out to you because they've heard about you, rather than you having to give them a cold call and then seek an investment. Same thing with customers and hires. So all aspects of running a startup, I think, is greatly facilitated by having a great presence in the public domain and the knowledge of the relevant people.
Okay, we have a question for Hakeem. This is from Shomali Chatterjee, who's a professor at Purdue University. She asks, how easy or hard is it to be a professor and a founder? Is it like having two labs?
That's a great question. Last year in, what was it, 2020? So in the spring, I was, like I said, we were starting to raise money. We had a MVP at that time. I was teaching a 250-person class, so computer organization. I had a baby, so it was insane. And I wouldn't necessarily recommend something like that on my worst enemies, just because it was a lot. But sometimes, it's one of those time periods when the greatest things happen. So we're actually able to, like I said, raise twice as much. The class went well. We had to go online. That was another aspect, was being in person and going online. And it is a bit much to balance both. But at the beginning, you have to be careful about time, is what I would say, is timing, I should say, because I'm on sabbatical right now, and then I have a leave of absence. So you have a few years through a lot of institutions that you can have off to completely focus on the startup. And I was trying to time that, so that I could have time off this year and next year and a little time after that to just focus on the company. Of course, I didn't predict a pandemic happening in the middle of that. The last thing I'll say is there's a number of companies like us that has helped to inspire us as well. So Katana Graph has Chris Rosbach, who's part of the systems community as well, and Keshav Pingali, who's at Cornell before going to Texas, and then also Samba Nova at Stanford has Chris Ray and Kunle, and then there's Data Chat at Wisconsin that has Jignesh. So there's actually, and then I actually know the founders of Databricks, Jan Stoica and Ali Gotzi, quite well. So there's actually a lot of companies of people who have academics, professors who have started companies and done quite well. And how they balance that, usually try and time it up with a sabbatical and leave of absence somehow. But you do have to do some work beforehand. So we were incorporated 1.5 years before that. I know it's by the grace of God that I survived that semester. And actually not just survived, but thrived quite honestly.
Question from Umesh Deshpande from IBM Research. How did your responsibilities change over the years since founding? And any surprises in what you had to undertake, or are you still technically involved? I guess sort of and I'll kind of rephrase it my own way a little bit. Like, were any of you, building the technology hands-on, and then transition to have more of a management executive role, or were you always a little bit hands-off from the technology directly itself?
So I would say, as a founder, and I'm not talking about as an employee of a startup, as a founder, a founder's responsibility is to do what the startup needs and not what the founder wants. Right? So roles can be defined. You can be a CTO founder, as an example, where you will stay a lot more technically involved. But again, that changes as the company grows. But in particular, as a CEO, right, it is generally that your technical contributions will fade over time. You'll always stay technical, but your technical core contributions, because you don't want to be the blocking thing on a customer deliverable when you have other things. You need to go raise money, which is a full-time job in itself, You need to go recruit, where at least 30% of your time should be going. Maybe we talked about team earlier. There'll be so many other responsibilities that will show up that are higher priority than being technical once your company has crossed the Series A, Series B stages, right? Sometimes sooner, sometimes later, depends on the company. But if you really think your core strengths on the technical side, right, the role should be different and not be that of a CEO.
Yeah, I mean,
go ahead.
Go ahead. We gotta do a random back off.
We'll let Shenzhen go.
Yeah.
Great, thank you. So we started out as a two-person team, both from the same synthetic biology lab at MIT. I was a postdoc. My co-founder was finishing up his PhD. He took a leave of absence. I quit my postdoc to be in an incubator in San Francisco to get the company started. So very, very technical, both of us, and we co-invented the technology that underlies our platform. But I think very quickly, we had a differentiation in terms of the roles, and I stepped away from the bench to focus solely on the investor relationships, customer relationships, as well as hiring. And I think that was very important for us to have somebody be in that CEO role and focus on those functions in the company, and not necessarily be tied down to the bench every single day. But that's not to say that I think that having technical founders is a very good thing. I can't imagine at this stage of the company someone not being involved with the invention of the technology, trying to explain it to different sets of people to raise an investment or to form customer relationships. I mean, we now have more people that have come in and joined the company that have formed the intimate knowledge, have gained the intimate knowledge of the technology, and are in a better position to do so. But to think about a totally non-technical founder that wasn't involved in the technology, especially early on, I think takes away a lot from the authenticity that entrepreneurs really should have in order for the company to grow into a successful one. Sorry, yeah. Go ahead, Aki.
Yeah, I was going to say that as a CEO, like what Niraj is saying, is that you really need to do what the company needs. For me in particular, or my situation, there's 3 founders. It was really based off of the 3 of us worked together for over 10 years. So Robert and I were co-advisors, and then a PhD student at the time, who's a PhD now, Ziming Shen. So it was his thesis. So we were advisors to begin with, but as we all know, he did the work. And so he's the CTO now, and he's involved in the technology and oversees that. And I have a very firm, grip on the technology, but I'm not writing the code. Otherwise, it would be held up, based off the other stuff. But being able to speak, to all the engineers and even hire there and everything, and then speak to investors and then speak to potential customers is what the company needs. And actually, as a professor, you're a salesperson because you're always trying to raise money. I tell people that if I want 5 students, 1 student costs about $80,000 at Cornell, so I need to raise $400,000 a year. So I need to raise about $2 million every 5 years or whatnot. So we're salespeople at heart, and we have to take something that's very technical, very complex, and then be able to make it, very accessible to a lot of different audiences and understand the audience. And so for the company to be successful, especially early on, it's required of the CEO to figure that out, how to talk to the different communities so that the company can be successful, and also keep the team together and help the team grow and stuff. So you're doing a lot, even if you're not writing code, that gets committed each day.
All right. Let's see, another question. There's been a recent trend to combine AI ML with systems research. It's a research area, it's a research topic. It's also a lot of businesses talking about it. Are AI ML techniques, used by your company or your recent companies, either internally or something that you helped support in some way?
So maybe I'll do a quick response there. Yes, we apply some machine learning techniques. One of the things that we do is we use a spot market to bring your costs down, but the spot market is very unreliable. It'll kill your instances. So we're running a stateful application for long periods of time, hours and hours or days. And so we can't wait for the signal. The cloud does give you a signal that they're going to terminate your application. And we're able to support applications up to 1 terabyte. So you can do the math. It takes more than 2 minutes to transfer 1 terabyte of state from one place to another. But we've been so successful that we've been running for 5, almost 6 months without a single termination for some of our runs. And essentially what we're able to do is, if the cloud itself is 4 nines, and if the spot is 1, maybe 2 at most nines, we're able to give you right around 3 nines of reliability. That's a large part of that is some of the machine learning and whatnot that we have applied to the problem. I mean, the secret sauce is in that ability.
Anyone else want to comment whether their company is using AI ML techniques or your products helped support such techniques?
So it depends on what you're trying to do, right? We've explored some things. I mean, there is a magic wand that people believe, hey, this pixie dust you sprinkle over a startup, you'll raise more money, or you'll suddenly become more attractive. I think, that only takes you so far from a marketing perspective. I think it's what Hakeem talked about. Is it core to your business? Does it make a meaningful difference to customers? And then figuring out whether to apply it or not to apply it, right, to the problem you have at hand. You might not always need it. Sometimes it can be helpful, right? And sometimes it is core. So I think it's, again, there is the marketing, PR aspect of it, how you differentiate yourselves, and sometimes people use that. But then also from a product perspective, right, is it making a meaningful difference to your customers? Right? Always it's putting the customers at heart. How does this help them? And looking at it from there, right? At the current company, given some of what we were doing, it actually took us a long time to get to the point where we're saying this might be useful. What we're doing hasn't changed for over 5 years whatsoever. But I think it requires a different kind of skill, different kind of problems, different kind of customer maturity to be able to leverage that. Which is not to say, hey, right, don't use this for marketing or PR purposes, right? It's not just about the technology when you're going to go to a startup, right? Figure out how to differentiate your company. And sometimes there is marketing at play there, and that's okay. But from the core technology perspective, again, it's about investing resources, investing time, it's investing bandwidth, and figuring out what difference does this make to my customer.
Yeah, for us,
Go ahead.
Since we use biochemical processes, inkjet printing, physical molecules playing around in DNA sequencing, statistics, thermodynamics, and pattern matching all come into play, and it's a very important part of our process. I think that's all we can say about that right now.
Yeah, I guess echoing some of Niraj, for Datrium, we looked at using such techniques to solve a number of internal problems. It wasn't core to the product we were building, but they all none of them were the fruit wasn't hanging low enough, I guess, for us to actually pull the trigger. There was needed to be a significant amount of work, almost research project to gain value from it. And in the priorities of, where do we spend our time and effort, that did not bubble to the top.
Got a question from Umesh Maheshwari. What are your views on the open source model, making money on support and special features? It seems that an increasing number of companies, especially in database systems, are using that model. Is that driven by the need for big customers to trust the code?
I think that there is a lot of, I think the trust question is one. I also think that increasingly the technologies that are used are driven by the developers, and it's the applications that that our customers care most about. The infrastructure is just a nuisance that has to be dealt with, which I think is part of why the cloud is being adopted as rapidly as it is. Sort of outsource that infrastructure for a lot of companies. And I think for application developers, it's easier for them to pick up and start getting using things that are free. There's a desire, easy to download something and give it a try, as opposed to go lobby for a big purchase order for a large amount of cash. And then once it's baked into an application, then it can grow. So I think that's part of, that is an avenue into getting technology to be deployed. There are others where the mission is dictated from on high, maybe something around security or something like that, and then the CIO is charged with solving that problem, and he's got a big checkbook, and he's willing to go buy something else. So I think it may kind of depend whether this is a sort of top-down need, that, or whether it's a developer-driven sort of usage.
Yeah, to formalize what Hugo said, right, there's an emerging body of work / theory, and the use of open source and a non-technical impact to your company will be in what people call PLG, or product-led growth, and which is what Hugo talks about. Someone adopts it, the developer adopts it, makes its way up the chain, create a footprint, right? But you peek behind the curtain, some of it's also in some sense being driven by investors. They want to see, how do you get better sales efficiency? How are you going to get widespread adoption without having to invest at $10 million in marketing every year to get broader visibility of your product? And it's not the only way to do it, but open source is a way to go around doing it, where you go look at, how do I just make this free? No one needs to worry about adopting it. Right? There's a significant difference between a free product versus open source. Right? A lot more trust in open source, and sometimes it's optics. Majority of people will never look at your code, but they want to figure out a way to deploy it. And it's helpful for the company because it will allow you a way to get broader visibility without and being able to compete with people that have way larger budgets than you. So there are different aspects of open source that will impact your company positively, but there's a trade-off, right? No such thing as a free lunch there. Monetization becomes hard. Are you going to run this as a service, right? What are the pros and cons? And it's a deeper discussion, but I think there's a lot of benefit to open source, and this also goes back to an earlier question when we talked about customer discovery. How do you discover customers? You looked at some of the open source projects that have come out of UC Berkeley and become large companies. By the time you have that open source project that's being adopted, you have your first 50 customers to talk to. Your first 200 users are hanging out on your Slack channel, right? You tell them what you really want. What are you willing to go really, give me a $250,000 check for? It's going to also help with things like that at early stages of the company.
Yeah, a couple things. Yeah, I mean, this is something that we actually review maybe every quarter, 6 months, open source. It's a lot of effort to to foster a community. And so depending on your business goals and whatnot, may or may not directly affect that based off of the amount of work, so the return on investment. There is some trust there, but like Niraj says, a lot of people may not look at it, but they want to know that they can. For us, there are some aspects that have to be open source since we modify, Zen and Linux, and those are GPL, and those are required to be open source. But you do have to think about your business model. I think about Docker. Docker is a big thing, but the business model and people still use the Docker. For the most part, runtime, but different APIs and stuff like that. But as a business model, didn't succeed because you're able to essentially not have to pay for the container and whatnot. So that was so I think that as a business, you have to look at how will it help you out, and kind of bridge some of those other aspects, the trust and giving back to the community and stuff like that. As a researcher, we believe very much in open source, and that's your artifact that you're putting out there for people to see. As a business, there's a lot of trust, like we said, but in any case, it's not a direct answer that you open source and you'll have a successful business. It's still a lot of work in between open source and successful business.
All right, getting down to our last few minutes. So everyone on this panel has a research background. Do you have any advice for graduate students considering startups versus other career options?
Don't make the mistake I made. When I graduated, very biased, where I spent the last few years of my life doing research. And the only place I interviewed at was, I knew I didn't want to go into academia, but the only place I interviewed at was research labs. Startups are a very different way of making impact, but I believe the impact can be much higher. It is sometimes hard to figure out if you're going down the startup route, where you might want to go. Where you'll have the greatest impact in will be a company that doesn't regularly make the front page of TechCrunch or any of the other publications that cover the startup area. And so figuring out by networking with colleagues, a lot of people that have gone over to the startup side of things, talking to people, if you have an industry-oriented lab at your university, go give them a serious shot. A couple of people told me I should have, I did not. Again, hindsight is always 20/20, but give it a serious shot because I think there's a much greater chance of making an impact. There's obviously also the financial upside of doing startups, which can be very significant, but that's neither here nor there. It's 9 out of 10 startups fail. But I think from the career aspect, from the impact perspective, I could not have paid money to get the education I've received working at or founding startups. So that's my 2 cents on the subject.
Yeah, a piece of advice that I received at some point was that I should get a job in a company kind of like the one that I would like to build myself. And that's not a brand new startup, but not too huge either. A few hundred employees, they have customers, so that you can understand what it is that you might be trying to build. So I think it's if you go to a very small startup, well, things are a little chaotic and they're not, there's a lot of processes and so forth that aren't in place yet because no one's had time to build them. And if that's your only view of what a business looks like, then you don't really know, well, what does it grow into? What does a well-run, highly executing or, business organization look like? So for me, that was, I ended up going to NetApp for a couple of years, which at the time was, I think I was around employee 1,000 or something like that, maybe a little larger than I wanted, but they were growing very rapidly thanks to the internet bubble of the late 90s. So very successful, very good at what they were doing, and it gave me much better understanding of what was data domain, where did it need to end up, what are the kinds of things that I needed to be thinking about building in order to be a larger successful company. I think if, on the other hand, you go to a very large organization, like let's say you join Google or something. Google is no startup. You're not going to learn much about what it is to do a startup by working at Google. So you'll meet some good people and do some interesting technology, but you're not going to get much of a feel for what it takes to get a business to the flywheel of the business to start turning. In choosing a place to go, I would say it's very important to choose the place with the best other engineers and employees there. You're going to learn the most from the smartest group of people that you can find. So, I would sort of use that as the #1 metric for, which is the strongest team, and almost wherever that is, that's a good reason to go join it. Some teams at a Google are strong, others are not so strong. So who can you learn from? And also in the future, the strongest colleagues that you have, those people will go on to do interesting things, and they'll invite the strong people that they've worked with to join them. So you may get such an invitation, but only if you've been working with them and they know you. So in terms of your career over time, by associating with the best people that you can be working with, in general, that's going to work out for you over time.
So, yeah, that's a great question. I tell my students all the time, I want to make you uncomfortable. I mean, in terms of career, too many students, undergrad, master's, PhD, go on the path of least resistance. So they say, Professor, why should I not take the $300,000 or whatever that company XYZ is offering? And I think that they miss out on is what we're talking about here, the ability to have impact. A startup is a very exciting way to take your skills as a researcher or PhD student, and you find one that fits you, and you're going to be able to have a significant impact. If it doesn't work out, then you can go and join one of those companies, and you'll probably be better off, actually. Probably start out at a higher position and a higher salary. So there is no loss when when a person goes outside of their comfort zone. I just don't see it at all. And I would like to see more people push themselves to not going that common path of, some of these very large companies. I won't name any right now, but they're large, and it's just easy to take your talents and then you kind of disappear within them. They're good companies, so I don't have anything negative to say, but I would just like to see more people display their talents and, grow with a company like a startup. And chances are you only do this a few times usually, 1, 2, maybe 3 times, unless you get hooked. But that's a different story. And for me, the last thing I'll say is I chose an academic path, but an academic path really is entrepreneurial. I would say you are running your own enterprise. You got to raise your own money. You're working with your own team. You're head of your own fiefdom, if you will. And then if you have the opportunities, and I've been looking for this, to then take some of those ideas and create a startup, is quite exciting as well. I've actually been looking for a PhD student to not take that comfortable path, like I was saying. So I recently found that person. So in any case, I think that a startup is a great idea and that, is not actually a risk. So I actually spend a lot of time saying it's actually not a risk. But you're gonna benefit from it, but you gotta get outside that comfort zone to figure that out.
I would say if you have the opportunity, the idea, the chances of funding, and the co-founder, it's all in place for you, absolutely go ahead and start it right away. But if not, if you're at the stage where you're wondering whether or not you should do a startup and you're coming out of academia, you're still in school, I would almost give the opposite suggestion that you actually don't have to rush into it. You could gain kind of indirect experience into a startup by going in and working for an early stage company for a couple of years, or work for an investment firm, a VC, and due diligence for the fund, and get a really nice view into companies and see what the investors are looking for, what causes the companies to succeed or fail. And then if you're still into the idea and the right opportunities and the founders and everything else comes into play, make it happen. I think that in my own experience, I don't think I'm in a position to give out advice yet. I've yet to succeed with my first startup. I'm doing it. I'm trying to right now. If you're going into it and you have everything on the line, it will be extremely stressful, and it'll be extremely joyful. It'll be a roller coaster ride, and it'll be extremely risky because you are statistically much more likely to fail than you are to succeed. So I would say, if everything is in place, and it most likely will not be, but if you have the right opportunity, go ahead and seize it. But if you're uncertain, you don't have to rush into it. I think there are a lot of different ways you can better prepare for it so that you're much more likely to succeed when you do start the company.
All right, well, thank you to all of our panelists. We've reached the end of our time. We're actually a little past time. Again, I want to thank all the panelists. If you, besides those who have attended live, it's been recorded to YouTube. People are actually viewing it on YouTube, not just through the webinar. And we have our Slack channel, and if you're interested in participating in the Slack channel, you're welcome to do that. We're going to end our panel now, and we're going to have a very short break and then start up our last session of HotStorage. So thank you, everyone, and hopefully we'll see you in person at some point in the future. Bye.
Thank you.
Thanks, everyone.
Bye.
Thank you.
Hello, can you hear me? So we are going to start session 4 of HotStorage 2021. The session is about characterization and verification. I'm session chair, and Yo-Yo Liu is the co-chair. I'm a computer scientist from Lawrence Livermore National Laboratory, and Yo-Yo is a professor from Tsinghua University. We have 3 papers in the session. 2 papers will be using machine learning techniques to improve file system and storage system. We would also have 1 paper that propose a new model tracking for developing file system. So let's start with the first talk. The first talk is titled Sentilog, Anomaly Detecting on Parallel File Systems while Log-Based Sentiment Analysis. And the presenter is Dean Zhang. Zhang is currently a second-year PhD student in computer science at the University of North Carolina at Charlotte. His research interests include reinforcement learning, large storage system, and HPC scheduler. His current research focuses on applying deep learning methods to anomaly detections and also automated batch job schedulers. So let's start the first video.
Hi everyone, today I will be presenting our paper Sentilog, Anomaly Detecting on Parallel File Systems via Log-Based Sentiment Analysis. This work is from UNC Charlotte and Iowa State University. Here is the outline. First, let's start with the background. Modern HPC systems are growing exponentially. We have many great supercomputers today, such as Fugaku, Summit, Teralyte, and Sierra. A critical part of them is parallel file systems. But as the scale is growing, there are more anomalies in running parallel file system clusters. Fortunately, parallel file system clusters provide a large amount of logs which record the runtime information. We can detect the anomaly from analyzing logs. So the log-based anomaly detection is possible and promising. Before seeing how log-based anomaly detection works, let's first look at what a real log looks like. Here is a snippet of real runtime logs from last year. This is a log content of this log. Some parallel file systems provide the log level in the runtime logs, but Lustre does not. It is not hard to look the source code for the log level. We probably can see many logs share a similar template since they are from a same login statement in source code. We say the logs from the same login statement have the same log index. These two have log index 1. For another unsimilar log, it has a different log index. So logs provide 3 types of information: log index, log level, and log content. So we can detect anomaly by them. Many previous work concentrate on log index, such as DeepLog and invariant mining. DeepLog studied the dependency between logs. For example, it can learn that the log index after 3 and 5 should be 1, 6, or 8. If the new incoming log has another log index, it means there must be an anomaly. For invariant mining, it can learn that the count of 1 equals the count of 3. And this example has 2, 1 and 2, 3. So it is likely to be normal. Another way to detect anomaly is by checking the log level. For example, we have 2 logs here. For some systems, the logs contain their log levels. If not, we can look source code for their log levels. And we can see log 1 is debug, log 2 is error. The error log shows that there is an anomaly. Third way to detect an anomaly is by analyzing the log content, but there is no much work along this direction. A simple method is to search some keywords like error and exception. Some work detects the thematic keywords such as synonyms and antonyms. But can we go further along this direction? These are 3 general ways to do anomaly detection, but for parallel file systems, some methods are not applicable because of 3 challenges. The first challenge is that for parallel file systems, log entries do not share any common identifier to denote their relevance. This identifier often appears in cloud systems. In this example, the 4 logs of HDFS share a same block ID, but the raster logs have no such identifier. So in parallel file system, it is difficult to group logs into sessions due to the lack of identifiers. So previous work based on log index is not suitable for parallel file system logs. For example, in systems where logs share a common identifier, like HDFS, we can group log into different sessions. For deep log, assume we have already learned such dependency from historical data. That is, 6 should be after 3 and 5. For session 1, 6 is after 3 and 5, so it is normal. For session 2, 6 is not after 3 and 5, so there is an anomaly. For invariant miling, assume we have learned such invariant that the count of 1 equals the count of 3. For session 1, the count of 1 and the count of 3 are both 2, so it is normal. For session 2, the count of 1 is less than the count of 3, so there is an anomaly. These log index-based methods work well in systems where logs share a common identifier, but for parallel file systems, there is no such identifier. Here is a typical log index sequence of parallel file systems. Since there is no common identifier, so we are not able to build sessions based on their identifiers. We can only build sessions based on timestamps. But how to choose suitable time windows? For deep log, 6 is after 3 and 5, so this log sequence should be normal. But if we choose a small window, we cannot see 6 after 3 and 5, so it will be predicted as anomaly, which is a false positive. If we choose a large time window, they have too many log indices, which makes it difficult to learn the dependency rules. For invariant mining, the count of 3 is equal to the count of 1, so it should be normal. But the same thing here, we don't know how to choose suitable time windows. If we choose a small one, the count of 3 is not equal to the count of 1. If we choose a large one, it may still violate the invariant rule. So log index-based methods are not applicable. The second challenge is the log level may be inaccurate. The log snippets are from BGFS. We can see the 3 log entries above are simply reporting variable values, but they are labeled as warning or critical instead of normal by developers. And the previous study actually suggested that such variable printing logs were reported as normal level in 95% of the time in multiple open source software. It shows that the log level may be inaccurate, so log level based methods are not suitable. The third challenge is that label data is difficult to obtain. Many previous works highly rely on the historical label data, but it requires a significant human efforts. For example, here is a runtime log in real cluster. We don't know whether there are anomalies, or even we somehow know there are anomalies. It is hard to determine which lines are associated with anomalies. So the methods depending on label data, such as deep log, are limited in such scenario. Let's see how Sentilog solves these challenges. For the first challenge, that is difficult to build appropriate sessions based on log index. Sentilog turns to use log content-based methods and propose to use sentiment analysis to understand log content. For the second challenge, Sentilog combines multiple systems login statements to avoid the inaccuracy of a single system. For the third challenge, Sentilog uses login statements in source code, which is naturally labeled. Let's see how we design Sentilog in detail. Here is the overview of Sentilog. We first collect the source codes from many parallel file systems, and then preprocess the raw log statements to build the training data. Then use a BioSTM neural network to train the sentiment model. This model will be applied to runtime logs from real clusters to detect the anomalies. Why do we use sentiment analysis? Below is the real snippets of logs. We can see that the log content not only has symbols and numbers, but also has natural language. More importantly, the natural language shows some sentiments. the anomalies are likely to be associated with negative sentiment log content. So we decide to train a sentiment model to analyze the log content, based on which we can predict whether there are anomalies. But how do we train this sentiment model is a problem. The runtime logs are not suitable because it will take significant human efforts to label the data. Using login statements from a single system source code seems acceptable since they have a natural labels log level, but they may be biased by a developer, so it is not a good choice. Finally, we decide to use log statements from multiple system source code as our training data because they have generic labels. Why these labels from multiple systems are generic? Let's see an example. As we know, some logs have BIOS log level, which we used an orange color to highlight. The fourth log's level is error, but it should be debugged. If our model is trained from this data, when we have a new incoming log which has similar content with the fourth log, the model will predict the new incoming log as an anomaly, but actually it is normal. The BIOS log level misleads the model to do the wrong prediction. How can we handle this? If we use another system source code as training data, it probably also has BIOS log level, but not in the same place. If we have more systems as our training data, the probability of being misled by a wrong labeled log gets smaller. That's why we say the label of log statements from multiple system source code is generic. From another perspective to understand this matter, more training data of different developers will help the model learn the real sentiments behind the logs more accurately. Then, let's see how Sentilog performs. In our evaluation, we utilize 4 real parallel file system logs as training data to train a sentiment model, and an automatic fault injection tool, pfault, to inject fault into running clusters, which are Lustre and BGFS, to collect the testing data. And our metrics are accuracy, precision, recall, and F measure. Since data is imbalanced, we care most about the F measure score. Here is a comparison between Sentilog and DeepLog. Since our Sentilog is based on log content and DeepLog is based on log index, so it can be seen as log content versus log index. For both Lustre and BGFS, Sentilog has a better F measure than DeepLog. Because in parallel file system logs, it is difficult to build sessions based on timestamp, which makes DeepLog not suitable and have many false positives. Here is a comparison between Sentilog and direct lookup. Direct lookup is to simply look up logs corresponding login statement in the source code and use its login level to decide whether it is an anomaly or not. So it can be treated as log content versus log level. We can see Sentilog has a slightly better performance than direct lookup in Lustre, but a significantly better performance than direct lookup in BGFS. It is because Lustre has a more accurate log level than BGFS. Here is a comparison between Sentilog and Sentilog self. Sentilog self is trained Sentilog using only the target parallel file system instead of mixed parallel file system. It can be treated as training on multiple source codes versus training on single source code. It shows that using multiple source codes as training data can improve the performance clearly. In conclusion, first, we propose to use sentimental analysis to understand log contents and detect the anomaly and shows its effectiveness. Second, we propose to train sentimental model using source code from multiple systems to solve the issue of lack of training data to avoid bias of each system. For the future work, we decided to explore the possibility to consider more features besides the log statement description, and also conduct more experiments to validate and quantify the generic sentiment across different software. That's all. If you have any questions, please feel free to ask. Thank you.
Thank you very much. Very interesting talk. Now we are entering Q&A session. As a reminder, if the audience have any questions, please post to the Slack channel. So we have the the first question coming from Philip from Dell Technologies, who is asking, your paper focuses on HPC, but do you think your log processing technique would also work for other systems?
Okay, it is a good question. And the idea to use log content to detect anomalies is a general idea. And we don't see any obstacles right now to apply it to other systems. But since we only do the experiments on the HPC parallel file systems, so we can only make sure it works on HPC. As for other systems, as long as it has the same characteristics as the HPC, our Sentilog can be used as well.
Thank you. We have another question from Yu from Tsinghua University. He's asking, what are the differences in the logs between HPC file system and cloud file systems?
For the cloud file systems, normally they have a common identifier between different logs. So we can use this identifier to build a session, which can logically connect different logs. But in HPC file systems like Lustre, mostly we cannot find such identifier to connect different logs into a session. So at this time, we can only use the fixed time window to build this session. But as we claim in our slides, it's not a very good idea to build such session. So we consider log content in HPC file system logs. Yeah.
So do you think the lack of session information in HPC logs can be addressed if they improve their current logging mechanisms, or is something fundamental in HPC systems?
Yes, I think it will be a very good idea to extend the login mechanism by adding the common identifier. But I'm not sure whether it is feasible in the real implementation, because in the file system, many times you need to consider the FID between different files, and it's probably not very easy to track the FID from different layers, from the distributed layers and the local file systems. So I think it could be a good idea to use this common identifier, but in real implementation, it could be difficult.
I see. We have another question from Wesley from IBM Research, who is asking, you mentioned the Summit supercomputer, and I believe it uses IBM GPFS as a parallel file system. So were there any reasons not to try Sentilog on GPFS logs?
Okay, it's a good question. Actually, we think to apply our Sentilog to many different parallel file systems, but actually in the realistic world, we need to do some automatically fault injection to the parallel file system to generate the anomalies, so that we can validate whether our Sentilog is good or not. But currently, we only have pfault as the automatically fault injection tool, and it only supports Lustre and the BGFS. So we currently only consider Lustre and the BGFS as the target systems.
I see. Yeah, great answer. We have one last question from Ben. He's asking, when you say multiple systems, do you mean multiple systems running same type of file systems, or multiple file systems, and how to detect biased log levels?
The multi systems we claim is that different parallel file systems. It could be the same type, but mostly in real world, like BGFS and Lasser, which is the BGF is written by C++ and Lasser is written by C. So it could be a different type. And we have explained part of it in the presentation that multi-systems can help to reduce the impact of BIOS locks from one systems. That BIOS is from the developer because the lock level is a very subjective thing. So for different developers, they may think different on the same login statement. So we believe more on the log content than on the log level. And probably our work can help the developers to make a good decision on the log level based on the log content.
Excellent answers. Thank you very much for answering all the questions, and it's very interesting and also useful work. So I'm happy to see future follow-up. Now we are going to proceed to the next talk.
Thank you. Thank you for all your questions.
So the next talk is titled "A Machine Learning Framework to Improve Storage System Performance." And the speaker is Abraham Umet. He is currently a PhD student at Stony Brook University. His research focuses on building self-adaptive system softwares, in particular storage systems and operating systems. Please play the next video.
Hi, everybody. My name is Ümit Akın from Stony Brook University. I'm going to talk about our work in machine learning framework to improve storage system performance. The number of tunable parameters in 4.1951 Linux kernel is over 1,000. There are parameters which are related to most of the Linux kernel components. Here are a couple of examples of them. The first one is read-add size. Read-add is a storage prefetching system. Its main objective is to improve I/O performance by caching future storage data based on the tunable per disk and per file read-ahead values. The second one is I/O scheduler. We can change I/O scheduler based on our workload needs, like low latency or high throughput. Yes, there are so many tunable parameters in the kernel, but why are they so important? Because they can affect performance and latency drastically. By tuning these parameters, we can gain so much performance. Do the default values or a single value work for all the time? Because if that's the case, we can benchmark the system and tune it once. The answer is no. There is no single value that works for everything. They are highly dependent on the workloads. As a first stage of our research, we mostly focus on the I/O subsystems, because if we tune parameters for I/O subsystems correctly, we can enhance I/O performance a lot. Since we cleared out why tunable parameters are important, now we have to figure out how we are going to adjust them. Can we adjust these parameters manually? The answer is yes. But as I mentioned earlier, there is no single value that works for everything, and then they depend on the workload types. That's why the tuning manually only works for a unique setup. If the manual tuning works for a unique setup, still, can we tune once and just leave them? This is possible, but not applicable for most of the times, because either the workload that we adjusted the parameters will change because of the software development or other things, or we will start running different type of workloads on the system. That's why we have to adjust kernel parameters dynamically. Even though we need to adjust these parameters dynamically, can we tune these parameters with a simple algorithmic techniques? No, it is not that simple, because there are thousands of parameters, and then tuning these parameters requires certain expertises. Plus, all these parameters are interdependent multivariables. We would like to do multi-objective tuning as a future work in our research. Because of all these reasons, we propose a new approach, which is KML, a machine learning framework for operating systems and storage systems. Now, we are going to go through the KML design principles. In order to make the KML work in kernel, we had to implement most of the mathematical and matrix operations from scratch using approximation algorithms. For each layer type and loss functions, we implement the function for forward propagation and another for backward propagation. We perform inference by creating the computation-directed acyclic graph of the individual layers. We compute gradients using the reverse mode automatic differentiation. Operating systems are sensitive environments where the precious CPU and memory resources must be carefully managed. Therefore, any machine learning implementation inside the OS must be efficient. Most of the operating systems disable floating point operations in kernel. to reduce the context switching, overheads, and then also unwanted exceptions. There are techniques to do floating point computation without the floating point units, like fixed point representation and quantization, but we used Linux kernel's native approach for enabling and disabling floating point unit in the kernel. We minimize the number of code blocks using floating point operations to reduce the number of context switches that would also have to save and restore floating point registers. We achieved this using asynchronous training. You can find more details in this paper. We designed KML to be as efficient as possible. We used log-free circular buffers to process and asynchronous to train on the input data. Since losing part of the training data could reduce the neural network model's accuracy, users must carefully configure the circular buffer size based on the sampling rate of the data collection. As we all know, kernel programming is challenging. We designed KML, the development API, to abstract away the external functionality. In this way, KML can be compiled both user and kernel space with an identical behavior. Users can collect the data using the KML data processing and normalization components, then train on the ML models on collected trace data in the user space. Other adjustments, such as trying different neural network architectures or hyperparameters, can also run in user space. When the neural network model is ready to be deployed, the user can save the model to a file, then load the neural network model with a given path to the deployment file in the kernel module. You can see the execution flow of the read-ahead use case on the right. User space training and kernel space inference is very useful, for sure, but we still support in-kernel training. There are two critical reasons why we support in-kernel training: performance and accuracy. One of the most crucial parts of the machine learning flow is collecting the training data. That's why getting accurate data from the kernel without any overheads is very important. In-kernel training also allows operating systems developers to build machine learning solutions using reinforcement learning. Using reinforcement learning, we can build machine learning approaches that can adapt themselves based on the feedback from the system. KML also ensures the inline data collection operations from the KML and then do not cause any deadlock. KML uses log-free data structures to avoid deadlock and to reduce the overhead of the data collection operations. You can find more information about this topic in the paper. We choose the read-ahead problem as our use case. As I mentioned earlier, read is a storage prefetching system. Users can provide the hints to the system through the system code such as fadvice or madvice. Our goal was to replace these manual or programmer-driven heuristics with an automated ML technique that quickly adapts to changing workloads and tune the read-ahead values as needed. We studied the read-ahead problem empirically. We tested DrugsDB with the 4 different workloads, 20 different read-ahead sizes, and 2 different storage media. We then built mapping from the workload type to the read-ahead value that provided the best throughput. The results show that there is no single value that maximizes the throughput for all the workloads. Moreover, the relationship between the read-ahead value was not linear, and at time exhibit long tails. As you can see, read random workload on NVMe example on the right. X-axis shows the configured read-ahead sizes, and y-axis the operations per second, which is the throughput. 256 was the default value for the read-ahead size. As you can see, the 256 is a suboptimal value for the read-ahead. In order to build our neural network model, we need to collect training data. We collected training data from the Linux kernel using trace points. These trace points track the file back pages. We used our own tool, Reanimator, to accommodate mmap-related trace points such as add to page cache and write back to page. In the read-ahead model, we process the collected data points every second and then extract the features at the runtime. We tried a total of 8 features, which we selected based on our domain expertise. We then experimentally narrowed them down to just 5 features that had the most predictive accuracy. Also, we confirmed that using Pearson correlation analysis. You can see the list of these 5 features. We designed our read-ahead neural network as a multi-class classification model. Our model has 3 layers, and these layers are connected with the sigmoid activation function to model the nonlinearity exhibited by the read-ahead versus throughput curves, as we investigated in the previous slide. We use the cross-entropy loss function and optimize our neural network using the SGD optimizer. We trained on the data that we collected by running the only 4 workloads on NVMe. We picked these training workloads because they were sufficiently diverse in sequentiality versus randomness. We measured the performance of our neural network using k-fold cross-validation with the K-stand. and found that our model reached an average accuracy 95.5%. Our evaluation goals were to prove that using KML and building the ML-based solutions inside the OS can offer more generalizable and adaptable solutions than aging heuristics, and hence improve performance with a minimal overhead. The red line in the middle of the graph is the line for 1x, which means anything above the red line shows the improvements. X-axis represents the workloads and Y-axis represents the performance improvements. To prove that our neural network model can learn abstract patterns, we tested our model under the workloads we trained on, as well as never seen before workloads that include complex mixed workload like a mixed graph. Moreover, while the training workloads on run an NVMe, our evaluations tried to dose and new workloads on an SSD. The results show that the read-ahead neural network can reach up to 2.3x better performance. Only for the read sequential on NVMe, KML actually lost 4% performance. All the other workloads are improved. This is because the read sequential maxes out the underlying hardware throughput, and then there was a very little opportunity to improve throughput. KML's attempt to learn and optimize read-ahead only interfered with the already optimal throughput. Figures show that how read-ahead neural network changes the read-ahead size during the RocksDB's workload running on an NVMe device, and how the performance improves overall. These 4 workloads, read sequential, read random, read drivers, and mixed graph, running actually back-to-back. For an entire execution, performance improvements around 40%. You can see the read-ahead size on the Y2 axis, which is represented as a transparent green, and throughput on the Y1 axis, and an X-axis represents the timeline. We ran the same benchmark 15 to 50 times and averaged the performance improvements. Figures show that there are fluctuations on the read-ahead size tuning. The reason for read random and mixed graph fluctuations is that we clear the cache after every run, and then when the benchmark starts, read access patterns are different than the rest of the execution. And for read sequential and read reverse cases, fluctuations happen because of for time to time, these 2 workloads are quite alike each other. Even though because of the mispredictions, fluctuations happen, as you can see, we can still improve performance. In conclusion, operating systems and storage systems are evolving to support an ever-diversifying range of the devices and workloads. For best performance, storage systems need to optimize for specific workloads and devices. Our preliminary results show that for read-ahead case study, we can improve I/O throughput by up to 2.3x with a negligible overhead. We plan to apply KML to other storage subsystems like I/O schedulers, storage networking, network file systems, and page cache. We are expanding KML to support other machine learning approaches like reinforcement learning, which can solve certain problems better than classification approaches. We also plan to extend our neural network architecture to support direct last cyclic graphs, which can fork and join. And here is the end of my presentation. Thank you so much for listening.
Thank you. Thank you for the excellent talk. Now we are entering Q&A session. And again, I have one question. Actually, I would like to clarify. So in your slide, you mentioned that the neural network is actually a multi-class classification. So I wonder, so from the input data, what are the outcome? Is it the classification of the workload, or is the recommended read-ahead parameter to use?
It's actually the classification of the workload. So we train on the 4 type of workloads, like the read sequential, read random, read reverse, and read write random. Whatever you run, the classification algorithm will say either whatever the closest one. And then based on the classification, we can say what would be the read-ahead value behaves the best for that particular classification. So that is true. So but we would like to build also regression. Like you said, it's going to regress to the predicted read-ahead value. So it's a larger space. It's a little bit harder problem to you.
I see. Yeah, just a follow-up. So I wonder for a system that might run multiple programs that may exhibit different behavior and characteristics, how would you output different optimal setting for different workloads, or it's just a system level one parameter as output?
If I understand the question correctly, so what we do for the training, so simply we run those for applications, and then we build this mapping to, this application, let's say this workload runs best with this read ahead value. So we have this mapping in the beginning, in the beginning of the things. Later, once you run your own workloads, whether it's one of those workloads that we trained on or something else, once we pick the one of the closest one, yes, it could be still suboptimal because the new workload that you run might not be well represented in the training data. That is true. So that's why we said that, so that as an extended version of this, we would like to do like a reinforcement learning. We would like to include actually more coming data and then extend actually the classes, the number of classes, and then things like that. Actually, yeah, sure.
Yeah, excellent answer. So we have a question from audience, Brian Kim from Syracuse University, who is asking, can you share your insights on why the effectiveness of KML changes depending on the underlying hardware? For example, it seems that the improvements on NVMe aren't as much as on SSD.
Yes, that's a good question, actually. So many people ask this question a lot. So it's mainly the reason why. So if you run applications on the NVMe, like the type of systems which is fast, even though you make mistakes, even though you do, let's say the tuned value is not the perfect value, since the device is so fast, it can actually tolerate those the stuff. So and if the devices get slower, bringing data from the memory, or if you make a wrong choice, blowing up the page cache or trashing the page cache has actually significant outcomes. So that when the device gets slower, the consequences of the making wrong choices are actually larger. So so that's why it behaves actually better with the faster devices. Yeah,
that's interesting. We have another question from Jian Kim from Florida International University, who's asking, parameter configuration is an interesting and long-standing problem of systems. So introducing neural network for this task introduces even more parameters to configure. So can you share your thoughts on the trade-off?
That's actually a good question. So I guess what what it means, basically, the more configuration to configure is basically the hyperparameters. I'm guessing that. So because it's what our final goal is. Basically, there will be so many configurations, true, but there will be no human tuned configurations. It has to be automated completely. So that the person who is using the system shouldn't touch anything actually manually. So that is true that the hyperparameters, also parameters that tune, that we introduced that, but the hyperparameters should be tuned by either before once the system is running the training, or before all these steps, not in the runtime. Hopefully, that's the purpose actually.
Great. So one last question from Leslie, IBM Research, who's asking, currently you seem to focus on a small subset of kernel interfaces and the tuning knobs, I/O related. So does it mean the work is mostly relevant for data-intensive applications?
That is true. So yeah, I would say not just the data-intensive, but any IO-intensive applications that we would like to tune, because the IO is so we get this question a lot by the reviewers too. So and the machine learning is such a system that it's computation heavy. So introduce with the machine learning more computation to reduce what? Like you are introducing an extra computation to do something, right? So improving the IO systems with adding just a little bit more computation, it is actually understandable, because if we can improve the system by 2.3x, adding 10 microseconds in the computation, which is fine. But that is true that if we add machine learning algorithms in the computation heavy systems, like a task scheduler, it's hard to justify adding that extra computation will improve the system or will make sense. So that's why we are mainly targeting, that is true, that IO related subsystems. And our next goal is actually not only targeting one knob at a time, but tuning multiple parameters together. So basically doing a multi-objective optimizations. Yeah, and because it's harder. So because the one object can say that, oh, this tries to reduce the latency, the other one tries to improve the throughput. They may conflict each other. So that's another challenging part, actually. Yeah.
I see. Great. Thank you very much for the talk.
Thank you so much.
Very interesting work. So now we're moving on to the next one. So we are going to start the last paper of the session. It's titled Model Tracking Support for File System Development. We have two speakers, Sue and Liu. Sue is currently a fourth-year PhD student at Stony Brook University. He is working with Professor Iris Sadok at File Systems and Storage Lab. His current work, as presented today, aims to improve or provide a normal model tracking framework will efficiently and thoroughly track file systems. And the second speaker is Liu. He's a second-year PhD student at Stony Brook University, and his research interests include file and storage systems, operating systems, and machine learning for system improvement. He's currently looking for a summer internship for 2022. Please play the next video.
Hi, my name is Yifei Liu from Stony Brook University. I'm going to talk about our work, model checking support for file system development. This is the work in collaboration with Nimble Research and Harvard College. I will present the first half of the talk, and my colleague Wei-Su will present the second half. Developing and maintaining a file system is time-consuming, complex, and error-prone. It requires many years of effort and careful implementation, and should be compliant with specific standards like POSIX. However, even the popular and long-lived file systems, bugs are constantly emerging every year. For example, ButterFS was designed 14 years ago, still reported 110 bugs solely in 2020. Likewise, bugs were emerging for ext4, XFS, and other file systems. The file system bugs have serious consequences such as data loss, system crashes, and data corruption. File system bug detection is a well-studied area which can be applied to assist file system development. We created a similar table with Tedra to summarize 4 types of work that detect file system bugs. Regression test suites run fixed test cases, but they cannot cover sufficient corner cases and new features. Fuzzing generates invalid or random inputs to reveal bugs. However, fuzzing either detects the limited type of bugs, for example, memory safety bugs, or requires human effort to design and implement checkers, making these techniques less convenient for assisting file system development. Machine verifiable file systems were rigorously verified regarding some aspects of a file system, like crash consistency, but they cannot be applied to existing file systems directly. Model checking verifies if the specification holds the model of a system. Existing model checking work was limited to certain bugs, for example, crash consistency bugs, or required an abstract model for file systems. But the file system model is difficult to build because file systems are complex and continuously evolving. To address the limitations of existing approaches and assist file system development, we proposed a new model checking framework, MCFS, to test file systems thoroughly and effectively. MCFS has 5 design goals. First, we want to explore the state space of file system thoroughly and check many corner cases. Second, unlike other model checking work, MCFS eliminates the need for building an abstract model. MCFS should not change the behavior of the file systems under investigation and avoid observer effects. Ideally, MCFS should support a wide range of file systems, including user space, internal, and distributed file systems. Finally, MCFS should have high performance. The basic idea of MCFS is that we run multiple file systems concurrently and perform the same file system operations, that is, system calls. Then we check if all the file systems have identical states. MCFS consists of 4 components. Randomized test engines are the driver processes. We use a do-or loop to issue non-deterministic system call sequences to each tested file system. We use the spin model checker to perform optimized state space exploration for a given set of system calls and parameters. Integrity checks verify that all tested file systems have identical states by asserting the equality of return values, error codes, file data, metadata, and directory structure. Integrity checks report a potential bug if they find any discrepancy. Abstraction functions convert concrete states into abstract states, eliminating information that is not of interest to us. Next, my colleague Wei Su will present the rest of the talk.
Thank you, Yifei. Hi, my name is Wei Su. I'll discuss the challenges we encountered when developing MCFS and how we addressed them. We mainly met 3 challenges: state explosion, false positives, and cache incoherency. Spin compares the states in a byte-to-byte manner to tell whether a state has been visited. This will cause state explosion because any small change to the file system image will lead to a new state, even though logically the file system didn't change at all. For example, ext4 updates its timestamps in the superblock on each mutating operation, even if it didn't actually make any change. The consequence is that state exploration will never complete because the state space keeps growing with every noisy change. To address this problem, we defined abstraction functions to calculate abstract states of the file systems. The abstract states, instead of the file system images themselves, will be used to distinguish unique states. It only considers directory structure, file content, and important metadata in the file system, and ignores noisy attributes such as timestamps. Another challenge was false positive. False positive means different file system behavior that should never be considered as bugs. We mainly encountered 4 types of false positives. First, different file systems may report size of directories differently. Second, the ordering of directory entries depends on the file system implementation. Third, some file systems have special folders, such as lost and found in ext4, whereas others don't. Last, different file systems expose different file data capacity, even though they are formatted on same-sized devices. We applied several techniques to prevent MCFS from terminating due to those false positives, such as ignoring attributes, sorting directory entries, excluding special folders, and equalizing free spaces. The last and the most significant challenge was cache incoherency. Spin needs to checkpoint and restore the states of the file systems when exploring the state space in breadth first or depth first search order. However, Spin cannot track the in-memory states of the file systems. For kernel file systems, Spin is a user space program and cannot access kernel memory. For fuse file systems, Spin cannot track their in-memory states either because they run in independent address spaces. Initially, we only had Spin track persistent states, but as a result, the file system became corrupted during experiments because of the incomplete state restoration. Then we developed two solutions. One is to mount and unmount the file systems before and after executing each operation. This will ensure coherency of in-memory states, but is slow and may hide bugs related to in-memory states. However, this approach is compatible with all existing on-disk file systems. The other solution is to provide the checkpoint and restore API in the file systems. This approach is efficient but requires implementing the API. To demonstrate the checkpoint and restore API, we developed an in-memory file system called VeryFS. This figure shows the architecture of VeryFS, and the green box highlights the checkpoint and restore API. The API comprises two ioctls. When Spin calls the checkpoint API, VeryFS saves the current concrete file system state in the snapshot pool. When Spin calls the restore API, VeryFS retrieves the appropriate snapshot to restore the file system state. Snapshot pool is a key value store for historic file system states. We developed two versions of VeryFS. VeryFS 2 uses more sophisticated data structures and supports more POSIX operations. Now let's look at the performance of MCFS. This figure shows the average file system operation rate of MCFS, shown in x-axis in log scale. We experimented with several file system pairs and various backend storage devices, as shown along the y-axis. For the ext2 versus ext4 experiment, using a RAM disk was about 20 times faster than using hard disk or SSD. This shows the benefit of using RAM as MCFS underlying storage device. The experiment was also 10 times faster than ext4 versus XFS because ext4 versus XFS used up memory quickly and began to swap. The VeryFS 1 versus VeryFS 2 experiment was 6 times faster than ext2 versus ext4 because of the efficient checkpoint and restore API and not having to mount and unmount the file systems. When developing VeryFS 1, we ran MCFS to check VeryFS 1 versus ext4. We found that VeryFS 1's content differed from ext4's at some point. It turned out that VeryFS 1 failed to zero out the new space if truncate method expanded the file. When developing VeryFS 2, we checked VeryFS 1 versus VeryFS 2. We found that VeryFS 2's content differed from VeryFS 1's after performing write operations that extended the file's size, thus creating a hole. VeryFS 2 failed to zero out the hole. MCFS discovered these discrepancies, allowing us to easily fix these bugs. In conclusion, we proposed MCFS, a new model-checking framework for file system development that can explore state spaces thoroughly and cover as many corner cases as possible. We developed VeryFS 1 and 2 with checkpoint and restore APIs. The APIs enabled MCFS to efficiently track the full state of a file system. While developing VeryFS, MCFS found real bugs and considerably boosted file system development. As future work will add the checkpoint and restore API to Linux VFS, thus eliminating the need for unmount and remount. We will also run more than 2 file systems and apply inversion programming. Finally, we'll take advantage of swarm verification to perform model checking in parallel. Please see our MCFS paper for further details. That's the end of our presentation. Thanks for listening.
Thank you for your talks. Thank you, Liu and Sue. Now we are entering Q&A session. So I have a question. So in your results, you showed the performance comparison among several different file systems and on different backends. I'm wondering what's the absolute time required for MCFS to check a common file system like ext4?
To check the file system thoroughly, it usually takes several weeks because the state space created by the combination of lots of existing file system calls and the possible parameters is very large. So it takes very long time to finish the experiments. But as experiments for performance evaluation, we run each experiment for like 3 hours and gather their operations rates.
I see. Yeah, just to follow up. So I have a notice that in the high-level architecture that you have been showing the integrity check in this MCFS architecture. So for integrity check, it seems like MCFS is comparing different file systems to see if they have identical stats. So just out of curiosity, so is it has some assumption like at least if, let's say, if two file systems both have bugs but output the wrong state, would that be would not be detected from this design?
So I think this could be possible, but we believe that the probability could be low, and also in the future we plan to experiment with multiple file systems at once. So, and then we could carry out inversion programming. So that could further decrease the probability of all the file system being checked have the exact same bug. And yeah, Yifei, do you have anything to add?
Yeah, I think yes, because we are differential testing. So if they have different, if they have the same behavior, so we cannot detect the bug. Yeah, that's basically our idea of the model checking.
We have one question from the co-chair Yo-Yo. He is asking, it's interesting to checkpoint the in-memory data structures for verification. So what are the data structures that are checkpointed? Are these data structures sufficient for verification?
So the data structures checkpointed are mainly the inodes and directory entries that are in memory. So these data structures are not meant for verification, but it is for cache coherency. So when the model checker backtracks and restores the file system into an earlier state, it could be this process could be safely done and won't cause any cache incoherency or corruptions.
I see. Great. So, well, we are that's the last question from the audience, and we are concluding this final paper in the session. And without a break, we are directly moving to the wrap-up session, which will be led by PC chairs.
All right. Hello, everyone. Just want to have a few brief comments to conclude HotStorage 2021. We want to thank all of the authors for submitting their work and for making excellent videos and answering questions. I'd like to thank all of our session chairs, our keynote speaker, and our panelists. And importantly, I want to thank all of our organizers who've been working for the last 6 months to make this event a success. For 2022, the steering committee is already planning. And I want to announce that they have selected the co-chairs of the program committee. It will be Sudarshan Kannan and Zhaosong Mao. And I'm sure we will hear more about the plans for 2022 in the coming months. And we hope to see you at HotStorage 2022, whether it is in person or virtual. Either way, we hope to see you next year. And finally, again, we'd like to thank our sponsors, ACM SigOps, for sponsoring HotStorage and giving it its home in cooperation with Usenix. Our gold sponsors, Intel and Samsung, that sponsored our Best Paper and Best Presentation Awards. And our silver sponsors, Dell Technologies and IBM, as well as Systore for giving us support in planning the event. Ujip, any final comments?
Yeah, I earnestly hope that all of the participants have enjoyed this HotStorage 2021, and I really appreciate your staying till the end of the workshop. And as for me, it's the same. Thanks all the participants, PC members, organizers, and steering committee members for the support. See you next year.
All right, goodbye.
Bye.